most extensive life support system, holding nearly 97% of our planet's water, regulating the global climate, cycling vital nutrients, and producing more than half of the oxygen in the atmosphere. This meeting is a follow-up to the Ocean Acidification Day of Action held in Monrovia on 8th January 2021, then organized by the Ocean Acidification Africa Network, the IAEA Ocean Acidification International Coordination Center, the Ocean Foundation, and Future Earth Coast in collaboration with the Environmental Protection Agency of Liberia, the National Fisheries and Aquaculture Authority, and the Liberia Maritime Authority. The meeting, however, we aim to promote and facilitate a community of awareness around ocean acidification to communicate, develop, and facilitate international activities on ocean acidification, including science, capacity building, and communication. And we are hopeful that this will be done through improving capacities, especially in developing countries. And we are talking about both technical and financial capabilities. 2, raising awareness. 3, information generation, exchange, and dissemination. 4, contribute to the development of information and data products, and providing input to future case studies for monitoring and research projects to fill gaps in knowledge and data. The meeting in Monrovia welcomed 50 participants in person at a local venue in Liberia, comprising mostly of local actors and partners. The wider ocean acidification community, however, joined the meeting via WebEx, an online virtual platform. Ladies and gentlemen, the event held in Liberia on the 8th of January 2021 produced a resolution to build on past training and research to promote and develop ocean acidification research in Africa. The resolution will serve to signpost and let members know what to do next based on regional needs and priorities. Based on the Ocean Acidification Network's activities and emerging trends discussed during the OA Day of Action in Monrovia on the 8th of January 2021, the following tasks and activities have been considered. Of course, taking note of the network's resource constraints, members of the network steering committee, in collaboration with partners and support staff, recommended the next course of action as an outcome of the ongoing event. Number 1, the network sees it befitting to ensure that we nominate further steering committee members from various backgrounds, including those from the natural and social sciences. 2, the Ocean Acidification Africa Network should also help to plan and prepare for hosting a side event at the soon to be hosted UN Decade of Ocean Conference to be scheduled soon. 3, finalize white papers for West, North, and East Africa. Currently, there is support from the Ocean Acidification International Coordination Center for the 3 regions to work with individuals and expert groups to finalize the paper, of course, with support from some of our partners, including Dupont, Patrizia Ziveri, Schultz, Peter Swazinski, and others, which we'll hope to mention as we go through the program. 4, discussion about support environmental research center in West Africa. As we mentioned prior to today's event, that capacity building and technical support for West Africa is lagging or lacking. 5, facilitating OA training in West Africa. 6, finalize term of reference for the steering committee, technical advisory panel, and the communications person that will help support and help host our website. 4, Ocean Acidification Information Exchange platform to help encourage and engage participation in OA science and research in Africa. 8, finalize the resolution, the draft resolution we have already prepared with support from the OA-ICC, Future Earth Coast, and the Ocean Foundation. The draft resolution we currently serve as the outcome for the Ocean Acidification Day of Action event held in Monrovia on 8th of January 2021. Needs to be finalized and further sign an MOU with the Ocean Acidification and the OAICC, and further develop a work plan with the Abidjan Convention, since that convention represents 22 countries in the West and Central Gulf of Guinea, to enable and facilitate ocean science and research. And lastly, as an outcome, to help schedule periodic ocean acidification steering committee meetings, which has been a serious issue for the past, since we hosted the second in-person steering committee meeting in Morocco, in Liberia in 2019 during the Blue Oceans Conference. On the notes, I say thank you very much. I look forward to interacting with you and engaging further with your thoughts. And I wish you a pleasant meeting. Thank you very much.
Thank you so much, Shek. All right, so now we're going to hear an address by Peter Swazinski, who will introduce himself and talk about his role as section head and director of the OA. Take it away, Peter.
Great, thanks a lot, Trevor. If you could, I would like to share my screen.
Yep, you're sharing content now.
All right, can you guys see that? Can you see that, Trevor?
Yes, we see it.
Yes.
It's coming through.
Yes.
Okay, excellent. So this is not so much an address, but it's a balance to what Shek just very nicely described, kind of the landscape of OA Africa in the previous talk. And what I'm going to do is just give you guys a call to arms on why OA science is so important. And I certainly know that I'm speaking a little bit to the choir here, but I wanted to nonetheless kind of set the stage for why we need to be looking at OA, ocean acidification. And I draw on my colleague, Rob Dunbar from Stanford, who I think said this very nicely. And Rob Dunbar is probably one of our best for reconstructing all kinds of past records, be it from sediments or corals, to then say something about how the ocean might be projected under different scenarios. So if you want to say anything about ocean acidification, you have to think about the biology at the same time that you're collecting data on the physics and on the chemistry. And over the last years, we've been incredibly inventive and creative in developing instruments that allow us to measure at very high resolution physical parameters and chemical parameters of the ocean. The Argos floats, as one example, have, I think, more than 3,500 observing platforms in the oceans, continuously collecting data on the physics and on the chemistry of the ocean. These are then telemetry back to servers that allow modelers to project ocean change into the future. So we got to talk about the biology in addition to the physics and the chemistry. And as Sam will say in a little bit, the biology, we don't have an instrument to measure the biological impact. So this is a little bit of the challenge. So I mentioned something about all this data being collected. I want to then jump into the work, the really pioneering work of Jim Orr, and a paper that came out in 15 years ago kind of set the stage for current and then future aragonite saturation in percentages. And without going into a lot of detail, you can see some dramatic changes in the aragonite saturation. For calcifying organisms, this is a big deal. I've replotted or taken an example of this data now at a much higher resolution. This is aragonite saturation index, or omega, mapped on our globe. And I wish I could turn it so Africa would be right in the center. But in the red and the yellows are indicative of more corrosive environments, and the blues are indicative of environments that are conducive to calcification or coral growth or shell formation. And it's obvious that this is a future projection, so this is towards the end of the century, and it might not affect us, but it certainly will have a direct bearing on our children. So this is a big deal, and I've highlighted with the yellow arrows here off to the left a couple of places off the coast of Africa that are actually projected to have significant impacts of this this aragonite saturation index change. So maybe some of you heard the IOC UNESCO's Brave New Ocean webinar, I guess you could call it, a couple of days ago, and I just have one excerpt from the most recent IPCC SROC report. This is this is on the ocean and sorry about the phone, the ocean and cryogenic, the ocean and the cryosphere, sorry. And I just wanted to highlight the ocean pH. This is the box in red, and you can see there are substantiated, consistent declines in all compartments of our oceans. So it's a very big deal. And going back to what Rob Dunbar has said, who's talked about all the different impacts of ocean change, from ocean warming to sea level rise to deoxygenation, ocean acidification is the one thing that has a potential to really impact all aspects of the ocean and of communities that rely on the oceans. So taking the omega global values and extrapolating them to pH, here's a global map of pH change, again looking towards the end of the century and highlighting again the coastline, especially off of West Africa. The upwelling regions in both these areas show some significant changes in ocean pH. So this is something that we have to look at carefully and systematically. I'm going to end this with just the IPCC projections. This is a time series data that is collected on the large island on Hawaii and Mauna Loa. This is the atmospheric CO2 in parts per million per volume. Today's CO2 value is 415 and still climbing. And I just wanted to say two comments on this. You hear often the 400 is a threshold value, or ideally 350 is a threshold value. From a temperature point of view, we're trying to get to below 2 or 1.5 degrees C. This is still to date not based on a tremendous amount of scientific evidence, but we're trying to kind of gauge how we need to, how the ocean needs to respond. So today's value is 415. It's still growing. As you can see, in almost the same slope. The seawater partial pressure of CO2 is also increasing, and then the pH record is declining systematically. And in fact, over the last it's down about 25%, and because it's a log scale, it's actually a very significant deal. And I'll end it with this. If you guys want to know what's happening in the future, you've seen the IPCC reports, and there are new reports coming out, I think even scheduled for this year. We don't know the response, how these seawater pH or atmospheric CO2 are going to change. There are some speculations and some modeling results on this, but we do, the optimistic note is that we do have the capacity to affect future CO2 levels and future seawater pH. So with this kind of quick overview, I wanted to end on the same slide that I started with, and that is, again, driving home that the biology is what we need to know in addition to the physics and the chemistry. And I welcome you to this OA Africa event. Back to you, Trevor.
Thank you so much, Peter. All right. That was a great launch to our event focusing on ocean acidification. Shek, are your special guests invited, and are they here with us as attendees?
Yes. First, we will hear from the Deputy Director General from the National Fisheries and Aquaculture Authority, Honorable Augustine Manubala. He's going to be speaking on behalf of the institution. And Ambassador Manubala is a maritime professional who worked over 7 years with the Liberia Maritime Authority and currently serves in capacity as a Deputy Director General of the National Fisheries and Aquaculture Authority, steering the day-to-day activities of the institution. So I will turn the mic over to Honorable Manubala for his brief statement.
Okay. 1 second, please, while I make Manubala a presenter. Check. How do you spell that, please?
Manoballah. Can type that to you in the chat room.
Okay, thanks.
I think that's okay. Almost here, Trevor. Okay, got you.
I don't see them with us. Could you confirm with me that they're here?
I just did. Let me do it again. He's following now, so. Yeah, Trevor, he's here, and I think he's just trying to unmute and start his video, but he's on the call and following.
Okay.
Yeah.
Yeah, I'm pulling him up.
All right.
Okay.
Okay, I'm seeing, yeah.
Augustine, thank you. We have you with us. Could you, it seems your mic is not connected. There we go. I'm unmuting you now.
Hello.
Hello, welcome. Okay, we can hear you now.
Okay, thank you. Thank you very much. Are you getting me now?
Yes, we hear you well. Go ahead.
Okay, thank you. It's a pleasure joining you and having a wonderful time here. Like Sheikh said, I am Augustine Manobala. I am the Deputy Director General of Administration of the National Fisheries and Aquaculture Authority. I worked before coming here at the Liberia Maritime Authority. I have a background in maritime studies. And so for me, it is a pleasure, especially joining you guys to have a conversation on this very important topic relative to the ocean. And so I'll begin to welcome you all and thank you for finding the time to participate at this event celebrating the Ocean Acidification Day of Africa by the government of Liberia, the Ocean Acidification African Regional Network, and the RAEA Ocean Acidification International Coordination Center on raising ocean acidification awareness and research gaps in Africa. I wish also at its very best thank our partners and the government of Liberia for their invaluable support in organizing the event. The National Fisheries and Aquaculture Authority is only too happy to host this very important event. As scientists, industry practitioners, and policymakers gather for this unique SAR event to create awareness on the implementation of the Sustainable Development Goal 14.3, there is a reason to believe that the year 2021 promises to be an important year for the ocean, with the inclusion of a stand-alone sub-goal for ocean acidification, SDG 14.3, we see new impetus at the international level to address the current opportunities and challenges that ocean acidification presents. African states, including Liberia, are confronted by serious decline in the ocean health. In addition to ocean acidification, marine pollution, overfishing, and IUU fishing pose a serious threat to the sustainability of the ocean resources. Additionally, the impacts of ocean acidification diminish the smell in fish, causing debilitating behavioral effects and an inability to network and locate food. The fisheries are already under pressure from poor fisheries management and a legacy of overfishing. More than 80% of the global fish stocks are considered depleted. Of the people who derive livelihood from fishing, 90% live in developing countries, with no exceptions to Liberia. The government of Liberia and the National Fisheries and Aquaculture Authority are keen to strengthen cooperation and build partnerships to address critical issues to support the sustainable management of the ocean and create the necessary conditions for blue growth in a way that benefits national economies and local communities. On the margin of the event, as we discuss, I look forward to our discussions with the hope that these discussions can continue in the future through order for a very successful and sustainable management of our ocean. Thank you all. It's a pleasure and welcome.
Thank you so much, Mr. Manobala. It's really an honor to have you here, and I really appreciate you joining us at this event and taking the time out of your day to be with us and listen to all of the talks we have here to offer about ocean acidification, which does link directly to fisheries and to sustainable fishing in communities. Okay, Sheikh, is there another address before we start the first section?
Yes, we should have a brief talk, hopefully a shorter one, from the Deputy Commissioner for Administration at the Liberia Maritime Authority, Councillor Yang Binta. He's online. I don't know, I'm not seeing him here, but he's connected since.
Yeah, Gabinto?
Yeah. Yeah,
okay.
I just send his name to you.
Thank you. I just made him a panelist. I'm going to pass the presentation off.
Okay. Hello, Councillor Binta. Okay.
All right, you're unmuted.
Okay. Go ahead.
Go ahead. We hear you.
Good morning to everyone. I've been asked to give a brief remark. I am Yang Binta. I'm the head of administration and legal at the Liberia Maritime Authority. This role for the last 8 years. So I'm honored to be here with the colleagues. Excellencies, international partners, dear colleagues, good morning to you again. I would first like to seize this opportunity to give special thanks to the colleagues, especially technicians who devote their lives to the science of understanding the impacts we have on our environment. Wherever you may be, I hope that you and your loved ones are safe during these troubling times. I thank you for the privilege of addressing the Ocean Acidification Day of Action follow-up event. From the Ipcc reports to the daily ecological disasters witnessed around the world, we are coming to understand the scale of ocean acidification's environmental effects, and only the shameless now deny the causes of our predicament. continue on the challenge and opportunities posed by ocean acidification and throughout the lifetimes of our children, grandchildren, the Malthusian effect will be kicking in with increasing frequency and ferocity. We are in the middle of one of those effects right now in the shape of the COVID-19 pandemic. Dear colleagues, through this peacemaking lens, we must see our work on the 2030 agenda and within the SDG 14, with its faithful implementation by us all. Speakers from the Ocean Acidification Africa Network, the International Atomic Energy Agency, Ocean Acidification Coordination Center, the Ocean Foundation, and the Future Earth Coast and other organizations will address us more in detail during today's meeting. The United Nations Sustainable Development Goals 14.3 target of addressing ocean acidification can be progressing positively due to the dedicated and well-organized groups involved. Still, the problem of ocean acidification, along with ocean warming and deoxygenation, continues to trend in the wrong direction. Ladies and gentlemen, time dictates that I wrap up my remarks, but I look forward to addressing you again, particularly the wider ocean acidification Africa community, so that we can further assess SDG 14's progress and action required as we advance upon the next ocean conference, UN Ocean Conference in Lisbon. I will conclude by thanking all of those within the Ocean Acidification Africa Regional Network, many of whom are present today, for the support they have given our work on ocean acidification awareness and research, and convey my best wishes to you for the year ahead. The Liberia Maritime Authority stands ready as a partner for Liberia and Africa as we strive to complete our objectives. I thank you for your attention.
Dear Councillor Ruto, this is Peter Swazinski from the IEA in Monaco. I wanted to, first of all, thank you for taking the time today to address us, and you really just delivered a powerful and meaningful and on-target message to our OA community, and I'm very honored for you to take the time and to set the stage for us in such clear terms. Liberia has played a tremendous role already since the Blue Oceans Conference in 2018, and look forward to working with Liberia and OA Africa in general much more in the coming years as COVID allows us to engage again in a more meaningful way. Thank you very, very much for your time.
Thank you very much, Peter, and thanks to the team as well.
Okay, so now is the time for us to move into the session where we're going to begin the presentations from the excellent scientists and researchers here. We are going to be starting our section on capacity building. So I'm pleased to kick this off. I just want to explain briefly that each speaker is going to give their address. I'm going to introduce them, and then they're going to give their presentation. During the presentation, all the attendees, as well as any participants, may send me a message with the question that you have for the speaker. And if we have time at the end of their talk and at the end of the section, we will select some questions from the audience to give to the speaker, and I will be doing that. So now we are going to start with this OA Capacity Building in Africa section. Many of our speakers have been actively involved in leading capacity efforts in Africa. We'll be talking about the GOA-ON network. we'll be talking about natural and social science interaction in OA Africa, the current status of OA capacity, the efforts of some organizations among us like Future Earth Coast to address ocean acidification, and the work of the OAICC in pursuing sustainable SDG 14.3 objectives and forming the community of action around ocean acidification. So a lot of good stuff coming up. Now I will be introducing our speakers who will share their wealth of knowledge and experience on each of these subjects with you, after which I'll pose a few questions to them about their work. Again, we encourage you to write any questions to us that you may have for the speakers in the chat. Okay, so without further ado, I'm introducing Nayrah Shaltout. Nayrah Shaltout is an ocean acidification expert and scientist and associate professor of marine chemistry at the National Institute of Oceanography and Fisheries, and one of the esteemed co-chairs of the OA Africa Network and founding members. Nayrah will be talking about the overview of the GOA-ON project. So, Nayrah, I'm passing the presentation, the presenter mode to you. Go ahead, and you may now share your screen with us. Nayrah, be sure to unmute yourself.
Hello.
Yes, we hear you.
Okay, I'm very happy that I'm joining you in this great event for Ocean Acidification Africa, who gathered a lot of expertise around the world, and who is contributed and did too much for ocean acidification research in Africa. Thanks for IEA, for GOA-ON, and for Ocean Foundation for supporting all events in Africa. And I'm very happy to share our experience during the last years and how GOA-ON, Global Ocean Observing Network, contributed in enhancing and enriching and supporting the research and acidification in Africa. This is an overview of the Global Ocean Acidification Observing Network activities. At the beginning, let me give a short introduction about the Global Ocean Observing Network. It's an international partnership, and it aims to document the status and progress of ocean acidification in open ocean and coastal estuaries and in coral reef environments. And it aims to understand the impact of ocean acidification on diverse of marine ecosystems and societies. And the last but not least is to support forecast ocean acidification condition. To achieve it, it has three main goals. The first is to improve our understanding of global ocean acidification conditions by determination of state of a spatial and temporal pattern of carbon chemistry and assessing the generality of response of ocean acidification through the documentation and evaluation of the variation in carbon chemistry mechanisms and the driving ocean acidification, including the biological mechanisms, and by quantifying the rates of changes, trends, and identifying areas of high tended vulnerability and resilience. The second goal is to improve our understanding of ecosystem response to ocean acidification through tracking the biological response in concert with physical and chemical changes, and by quantifying the rate of changes and identifying the locations and species that is highly vulnerable or resilient to ocean acidification. The third goal is to acquire and exchange data to optimize the model of ocean acidification and its impacts. And this can be achieved by providing spatial and temporally resolved biogeochemical data to used in parameterization and modeling processes for future forecasting. So, to observe on global scale in order to understand the ocean acidification, also to collect information and data products that can inform policy and public with a response to global changes of ocean acidification, the status and the impacts of ocean acidification. And to get these, or to achieve this, we need sufficient data to develop the predictive skills and early warning system. This is how GOA-ON grows during since beginning in 2013. This is the first numbers of participants that participated in the GOA-ON network. It was 150 scientists from 31 countries at the beginning of 2013, at the launch of the GOA-ON 2013. And now how GOA-ON spread its impact and help and assistance in gathering about 800 scientists from 105 countries. And this is a description about the regional hub. GOA-ON to work effectively and to work in a coordination way. Encourage the formation of regional hubs to enhance collaboration on smaller scale. If we need to have a global picture, we need to put into consideration a smaller scale to collect all these regions together to have a full and clear picture about the status of ocean acidification globally. So they encourage the formation of regional hubs to work in a smaller regional scale in more relevant geographical areas. And this regional hub help to facilitate regional coordination, foster collaboration, and sharing ocean acidification monitoring expertise, and establish best practices for their regions. Each regional hub tends to have a different focus and scope according to their habitats, coastal areas, biodiversity distribution, and the impacts. There are currently 7 regional hubs under the umbrella of GOA-ON network. It's North America Hub, Pacific Islands Hub, LAUCA Latin American Hub, Westpac Hub, Western Pacific Hub, Australia Hub, Africa Hub, Latin America, LAUCA, and the latest Pacific Islands. And I think I said Africa. And for this, GOA-ON supports sustainable, it's going to support Sustainable Development Goal 14, which is live clean water, and has committed to expand a spatial and temporal coverage of ocean acidification observation around the world in a voluntary commitment, and supporting the target 14.3, which is minimizing and address the impact of ocean acidification, including scientific cooperation at all levels. The related indicator asks for average marine acidity, which is pH measured, and the dissemination of the indicator's methodology, which is in accordance with IUC UNESCO, which provides guidance on how to carry out measurements following the best practices established by experts in the ocean acidification community, and explain how to report collected information at the different regions and the different levels. GOA-ON is a network, is integrated international research effort, which is closely linked with other international research programs. And the diagrams in the screen, you saw that now on the screen, documents the primary international entities responsible for coordination with GOA-ON activities, which is Ocean Acidification International Reference User Group, Global Ocean Observing Network GOES, Intergovernmental Oceanographic Commission UNESCO, National Oceanic and Atmospheric Association Ocean Acidification Program NOAA, private sectors and foundations, UN communities of the Ocean Action, International Ocean Carbon Coordination Project on the top, International Atomic Agency Ocean Acidification, and research funders, national and regionals, Scientific Committee on Oceanic Research Score, the Commonwealth Blue Charter, Future Earth, World Meteorological Organization, WMO. One of the high and the top affected, one of the highest effects on capacity building on the different peer-to-peer program. Peer-to-peer program officially launched during the third GOA-ON meeting science workshop in Hooper's in Australia 2016. And it works for helping in a scientific mentorship in three main pillars. Scientific mentorship program that matches senior researchers with early career researchers through knowledge exchange between the mentor and mentees, through facilitating the transfer of knowledge, skills, and data, and collaboration in different projects, and in enhancing ocean acidification research between the mentors and mentees through inclusion of different projects. Okay. And
I need to ask you to wrap up your talk in the next minute. So
okay.
we can still move on to the other events.
I will go through the next. Okay, and other one is increasing capacity building through direct assistance, through training, one in-person workshop by a highly qualified experts in ocean acidification research all over the world, and through distributing the kits. This is peer-to-peer program in numbers. 10 new mentors signed up in 2020, and 25 mentees signed up, joined the network for the peer-to-peer program. And the active pairs in the last communication were 39 pairs in 2020, 22 pairs in 2019, and 60 pairs in 2018. And now we are going to keep on in a box is a low-cost kit used for collecting weather quality ocean acidification measurements, and it's distributed to scientists in 16 countries in Africa, Pacific, small islands, and developing states of Latin America. GOA-ON, in collaboration with Ocean Foundation and Future Earth, provided kits in a box for different countries in Africa that help in initiating the research and collecting data for biological data, chemistry data for areas that have no previous information about ocean acidification or chemistry of carbon and marine in their coastal area. And GOA-ON also provides videos that explain how to use these instruments, and it also provided standard reference material in the kits to acquire and to provide to ensure that the data is of high quality data. So it's not just a capacity building, not just training, in-person training, but they help different countries in Africa to start collecting information about basic information about ocean acidification and to get a step forward for ocean acidification research and its impact on biology. Thanks a lot.
Okay, thank you, Naira. So unfortunately, we don't have any time for questions for Naira right now. If we have time at the end of the session, we'll come back to you. Right now, we're going to move on to the next talk. Dr. Patrizia Ziveri is going to be presenting to us. Patrizia Ziveri is a research professor of the Catalan Institution for Research and Advanced Studies at the Institute of Environmental Science and Technology at the University Autónoma de Barcelona, Spain, and her work centers around the threats to the marine environment at various timescales and complexity from ocean acidification and climate change through the dispersion of impacts of marine litter and microplastics. She's studying a lot of different ocean change, including ocean acidification, and she's also coordinating different research activities like the Marine and Environmental Biogeosciences Group, and was the scientific director of that group from 2015 to 2020. So welcome, Patrizia. Thank you so much for joining us. I'm going to pass the presentation over to you now. Okay, you can now share your screen with us.
see it correctly, or do you see it, or I have to switch? Because I have two monitors and I never know.
I see the presenter view, not the view you want.
Okay, this one?
Yes, there you go.
This is correct. Okay. So first of all, it's a pleasure to be here, and I'm really happy to contribute to this discussion on promoting ocean acidification awareness and research in Africa. And also, it's great to have a follow-up of the Ocean Acidification Action Day in January. I also want to acknowledge, of course, the organizers, so the Ocean Acidification International Coordination Center, of course, Trevor and Peters, and GOA, as well, of course, Sheikh Sharif and collaborators, because really they were the initiator of this initiative. And thanks again also for the great opportunity to be in Liberia in 2019 at this Blue Ocean conference. That was really an important event. So what I want to talk to you about today is about research in Africa. And of course, we are thinking about biological and chemical data that are absolutely needed for understanding ocean acidification. But we also need to think about the social component. And of course, I mean, we are aware that the human population has become really a central it's a dominant component in the Earth system. So basically, what we need to address is also the system, the social system component. And when we think about the social system impacting the Earth system, is that we are impacting, of course, perturbing climate, ocean, coastal, and we think about some dramatic events that we are causing to the marine environment, like the coral bleaching, loss of keystone species, or the simplification of key marine ecosystems, so loss of biodiversity, but also impacting primary production, fish stock, and so on, and also biogeography. And of course, there are many processes, many drivers that are happening in the ocean and in the marine environment, the coastal system. And we think about ocean acidification, of course, is the discussion of today, of course, warming that is happening also on land, also drought on land. Here you have a picture from South Africa, precipitation pattern, as well as extreme events. Here you have some picture from Ghana due to like major destruction due to sea level rise. And so on. So, I mean, we have a major issue here interacting the natural system, of course, with the social system. And of course, these drivers are causing major changes and major issue of sustainability. So we have food security issue, we have water supply, public health, also poverty, increased conflicts due to environmental resources, lack of environmental resources, and also increased environmental injustice. And what I want to focus here today about the importance of integrating natural and social science, and I want to focus on a very important sector in Africa, that is fisheries, and it's really relevant for people in Africa and people living on the coast. Here is a FAO drawing of consumption of protein from fish, and when you look at Africa, you see this color code, and you see that fish protein in Africa, particularly, for example, here in the region of Gulf of Guinea, where Liberia, Ghana, Nigeria are, you see the fisheries industry is very key. And it's, for example, in this projection, say more than 30% of protein come from fish. And this is an issue because also when we see about forecasting and projection due to the growing population in Africa, but also for the increase in capita income, it's expected that Africa demand for fish will increase at least 30% by 2030, so only in a decade. And this is an issue, not only because, of course, there are resources needed in the projection, but also when we look at the impact of climate change, including ocean acidification, you see that, so this is a plot of the projected change in maximum catch potential. This is a report from the World Bank, Climate Change and Marine Fisheries in Africa. And you see the main issue here that I want to raise when we look at fisheries and the impact of these main drivers is that the projection are for 2050 that you have a drastic decrease in this major resource, that is maximum catch potential. And again, you see a decrease all over Africa, but specifically also you see a decrease, a large decrease here in this critical region the Gulf of Guinea. So it's something that we need to address when we think about ocean acidification impacting coastal systems. And one of the approach that has been used also is this community-based marine resource management and co-management. And this is key also for adapting a sector in fishery that is important and dominant in Africa, that is the small-scale fisheries. And this community-based marine research management has been also developed in some other sector, like in agriculture, for example, and it's been shown to be helpful for forecasting conflict resolution, also for responding to climate variability, and also for addressing sustainable development. So it's very key, as I mentioned, that we have to encompass these practices and also find this way of basing science and politics together. And again, this sector of fisheries is very important. I mentioned there are many people that depends on these economic opportunities and also in food security related to fisheries, and particularly local community and coastal ecosystem. But there is also a sector, and I want to give an example because we are just starting to work on that is overlooked. That is actually the importance of gender in this sector. And I think social study integrating science and so natural science and social science, they should really address key sectors for example, in fishery. And in terms of genders, it's been a bit, as I said, overlooked aspect. And women, in fact, in the fisheries are making up to 50% of the fisheries workforce globally, and they participate in every stage of the fish value chain, both in commercial and small-scale fisheries. And this is something that we just started, and I think hopefully we can develop this also in the Gulf of Guinea. We have some ideas also discussed with several people and with Sheikh, because we would like to be able to understand more about the role of, for example, in this case, gender in small-scale fisheries, and integrating the knowledge that we have in basically on the impact of ocean acidification, climate change on the biology, but then also on the people, and how we could find solution. And this specifically is a case study from coastal Kenya. It's actually in Lamu County. And the idea is really to work there and contribute to the role of women in sustainability management and fishery resources. And this is in collaboration with a colleague of mine, is Victoria Reyes. She's an anthropologist. She's an expert in local indigenous knowledge. And just to conclude, what I wanted to highlight, and hopefully we can discuss a bit more later, is that really when we think about developing the science, developing the monitoring, developing the knowledge in biology and chemistry, we also need to think about how we can integrate this with the socio-ecological risk assessment related to ocean acidification and climate change. Also, we would really need to develop this social study for better adapting to the changes that are happening, and this approach of co-management. And just the final point is comprehending the threats faced by the ocean required to adopt a multidisciplinary approach. So again, as I said many times, we need to integrate the social and natural sciences. So thank you.
Thank you so much, Patrizia. You bring up some excellent points about integrating social sciences, and particularly your focus on gender. I just would like to ask you, what you're looking into, is the implication there that ocean acidification could directly or indirectly, especially affect women in East Africa or West Africa?
So it's not only about ocean acidification, but indirectly, yes, because, or directly, as you said, because if ocean acidification and climate change are impacting a very important sector where women are contributing more than 50%, of course, they will impact also, in a way, the gender issue in the regions. So,
okay.
There is actually what I wanted to say. There is very little known about this. Very little known about the gender perspective on climate change and on ocean acidification impact.
Great. Before we go, one last word from you. What recommendations would you make to fellow scientists interested in looking at the intersection between the biology and the social science? Any words of advice?
The way I see it is that often I'm a natural scientist, I'm an oceanographer, and so I always see the perspective of the chemistry, biology, biogeochemistry, and usually when we have a component in our project is social, we tend to just add it afterwards, or it's very hard to integrate it since the beginning. And I think the challenge will be that when we design or when we develop a research program, we try to develop thinking about the integration since the very beginning. So same here with addressing ocean acidification in Africa. I think we need to think about different regions in Africa, what are the needs, what are the key sectors that we want to address, and also key social groups that we want to address.
Okay, thank you so much. Patrizia Ziveri, everyone. To the attendees who recently joined us, just remember you're free to write questions into the chat box addressed to me, Trevor Eakes, and I will try and incorporate some of those questions for our panelists into the conversation, time allowing. Okay, so now we're going to move on to the next talk given by Sam Dupont. Sam is a senior lecturer at the University of Gothenburg, Sweden, and an ecophysiologist with over 15 years of experience working on ocean acidification. He's also been a focal point for a lot of capacity building going on around the world and for doing many things in Africa. So, Sam, I'm passing you, presenter.
Thank you. Yeah.
There you go. You can share your screen now.
All right. And here we go. Hello, everybody. It's a real pleasure to see old and new friends as usual. So during the next 6 minutes, I will try just to give a brief overview about the current status of the capacity that we have for ocean acidification research in Africa. But before that, I wanted to have a little bit of the bigger picture, and I checked, the Sustainable Development Goal in general, and I focused on the 14th, which, as you know, is about water and ocean. And I just wanted to have a look at what is the situation in Africa, how much Africa is actually delivering in terms of addressing SDG 14. And that was the picture in 2018. And I made a color code, so dark black is really, really bad and green is really good. And we could see that actually Africa was doing relatively well. Some countries were actually doing very good. Mozambique was one of the best in the world at the time. But what is really encouraging is to see how things evolved in the last 2 years. So that's the picture for last year. And what you can see is that I had to add new categories in blue because Africa is doing better and better. And as you can see, things are moving into the right direction. So Africa is doing a lot in addressing SDG 14, and you can compare the two maps side by side. And what is really exciting is that 91% of all the countries in Africa made progress. And also the best country in the world is in Africa. And also 44% of all the African countries are above the world average. So Africa is doing massive progress in addressing the SDG 14. So what about acidification? Acidification, as you know, is a 14.3. And unfortunately, things are not moving as fast for that field. So as you all know, despite having this huge increase in number of publications, only a few are coming from Africa. And it's also true for monitoring initiatives. So you have less monitoring initiative over there. And there are many reasons for that. It's lack of infrastructure. There's a lack of access to equipment, sometimes lack of training, and of course, money. It's always a limitation everywhere. But to have a better picture, in 2016, the IAEA organized an expert meeting in the context of the IN project, and we gathered a bunch of experts to design a questionnaire that has been sent into different partners in Africa to have a snapshot of what was the situation in terms of infrastructure, equipment, and knowledge for ocean acidification research. And on average, that's the picture on the left, you could see that some countries were in really bad shape, like it's a category 4. So in that case, it's not access to good quality lab, like The problem was also like lack of knowledge, of course, and so on. When the green was where you had everything already in place, like good lab, good expertise, good people working on it and already publishing it. But you can see that some area need much more support, and in particular the west part of Africa, where the east coast was doing much better, where you can see like all the green part on the right of Africa over here. But then you could actually, this was for the average situation, but you could see that if you check the worst case, like it means like certain labs or certain teams within the country, you could see that there were some red and orange more or less everywhere, meaning that there is a huge need for collaboration within country and between countries. So thanks to that, we could organize a little bit more structured training. And we had a continuous support from different sources, from the Ocean Foundation to AICC, Future Coast, Earth, and many others. And you can see that many courses or training has been organized in the last 5-6 years, and there will be more. And actually, what we are doing now with the IAEA is an evaluation of what happened after all these courses for all the applicants. Were these courses useful? If not, why? To try to improve future training. But the message overall is that whatever you have, you can do something. And that was really the core of the training we are giving now, is basically, this is what we did in Mozambique. So we arrive on an island with just a basic building, and in a week we could build a lab and collect data. But even if you don't have that, there are still stuff you can do. And now we are working in developing simplified methodology. So what can you do if you just have a basic lab, few beakers, access to the sea, and a few microscope? And we have an example here of a document that you can use if you want to do very simple experiments. And we are using that now in the context of the WIOMSA funded project on ocean acidification on the east coast of Africa. And we organized like 2 training, one in South Africa, one in Kenya, where we started collecting real data and testing real hypotheses. So just to show that, of course, everybody would like to have more. We want more lab, we want more equipment, we want more training. But even if you have very simple lab and basic equipment, you can do really good science and test really good hypotheses. And it's still in action. This is an example of people working in Mozambique, again, using this simplified methodology and collecting really good data, even in time of COVID. So to show you that it's still possible to do good science today. So overall, there are some challenges in Africa, but also Africa is moving forward really well when it comes to SDGs. So things are developing. There is a lot of diversity and collaboration happening. You have a lot of support to the OAICC and others. And more importantly, a lot of creativity and energy. So Africa is more than ever a land of opportunity. So you can act now, even if the capacity is not as good as in other parts of the world. There are stuff that you can do, and you have like support and material to do so right now. Just to give you to finish with one success story. So the story of Carla, who has a movie later, I think, during the event today. So Carla had the first contact with acidification in 2016 during a training in Mauritius, and since then really developed ocean acidification in her country, achieving now, she's just finishing her PhD, and she will defend soon a PhD in ocean acidification that can really be used as an example, because she started from scratch and in parallel developed chemistry and biology. So she started monitoring and she did experiment in the lab in a really well-designed way. And so if you're interested, I guess there will be opportunity to see her PhD defense very soon. So thank you for your attention, and I'm happy to keep working with you in developing capacity and use the amazing energy you have in Africa to move and address ocean acidification.
Thank you so much, Sam. Great talk. Anyone, if you have questions for Sam, send them to me. I wanted to ask you, Sam, it's kind of the maps you showed of Africa. Some might be surprised to see the many African countries progressing and doing a fairly good job on SDG 14. What do you think some of the reasons might be that the African countries have made progress in that area, or some of the factors involved in that success?
I don't really know. I think they use different types of I think to evaluate this success, they have like indicators, different types of indicators. For example, I know in many African countries they implement marine protected areas, for example, which is something that will work for every stressors, acidification, and many others. So that there are some initiatives like that actually contribute to this increase in performance for the SDGs. But there are some really nice reports if you're interested. Every year they publish report about progress for all the SDGs. That's why I extracted the data.
Great. Since we have time, you mentioned simple experiments as a way to still move forward and investigate questions. Can you name one simple experiment that's been done on
Yeah, absolutely.
the organism and the method?
So basically what we did is like when we arrived in South Africa and Kenya is like, what can we do with what we have? I think it's always a good approach for these kind of trainings. And basically we realized that we can do fertilization assays that have been used in ecotoxicology for a long time. So basically what you need is to go outside, collect your organism of choice, spawn them, which is like, collect eggs and sperm, and then you can use these fertilizations, like how successful is the fertilization under a different pH scenario. And you don't even need fancy equipment to manipulate the chemistry. You can just use a CO2 bottle and bubble in seawater and mix and have the right pH. The only limitation, the only thing you really need is a way to characterize the carbonate chemistry, which is pH and another parameter like alkalinity. But now with the GOA-ON in a box that Naira mentioned, you can actually do that with simplified methodology. So that's basically one example of what we developed. But there is a methodology available. So if anyone wants it, just write to me and I'll share it with you.
Yeah, you're also welcome to share. I think you might be able to write to everyone and post links in the chat. That's another way to share. Thank you, Sam. Okay. And now I'd like to introduce to you all Dr. Kaya Schultz, who's an associate professor with the School of Environment, Science, and Engineering. And Schultz did their scientific work and is interested in the potential impacts of ocean change, the biogeochemical element for cycling and feedbacks in the Earth's climate system, as well as assessing potential benefits and risks that climate change poses, which could be very useful for our marine ecosystem restoration efforts. So I'm going to pass you the mic now.
Yeah.
All right.
Good morning,
you should be
everyone.
able to share your screen.
I will give it a go. Can you see my screen?
Yes.
Excellent. All right. Good morning, everyone. And it's great to see many of you who have met 2 years ago in Monrovia at the Blue Ocean Conference, which, I still have fond memories of. Today, I would like to talk about Future Earth Coast's effort to address ocean acidification and give you an example. But before I start, what is Future Earth Coast? Future Earth Coast is a global initiative that supports sustainability and adaptation to global change in the coastal zone. It is the core project of the broader Future Earth project or community, providing knowledge and support to accelerate transformations to a sustainable world. Some of you might remember the land-ocean interactions in the coastal zone project. That was its predecessor, which delivered more than 25 years of experience. And Future Earth Coast supports transformation to a sustainable and resilient future for society and nature at the coast by facilitating innovative, integrated, and impactful knowledge mobilization. There are basically 3 linked themes in Future Earth Coast. First up is dynamic coasts, then human development and coasts, and then third, pathways to coastal sustainability. And all these themes basically center around our coastal future and are interconnected. And one of the activities of Future Earth Coast are so-called coastal assessments, which are expert-led rapid assessments of state in terms of socioeconomic, but also the physical state of coasts in various regions. And in the context of ocean acidification, one very important physical parameter we already talked about and touched upon is obviously pH. And here I've pulled up a graph from a recent publication, which shows in the colored lines time series going back to the 1960s in various oceanic regions and the development over time, but also the seasonal variability. And when you compare these colored lines with the variability in the open ocean, which are the black lines, then what becomes very obvious is that in the coastal ocean, compared to the open ocean, the pH variability is generally much, much, much higher. And that in many cases, we already also have a much lower pH kind of baseline than in the open ocean. And of course, that makes coastal regions in particular vulnerable to ocean acidification. What causes these variabilities in the coastal ocean is mostly biological activity, so respiration or photosynthesis, but there is another process that can impact on considerable pH variability. And that process is so-called upwelling of deep water. It is mostly prevalent in so-called eastern boundary upwelling systems, which are marked here in red, which are basically the California current, the Humboldt, Peru, Chilean upwelling system, the Canary upwelling, and then here in the Gulf of Benguela and of Namibia. And it is driven by mainly prevailing winds that run equatorwards and drive the movement of surface waters offshore, which is then replaced by colder, deep water that is nutrient-rich, but also naturally low in pH. However, upwelling is not only occurring in these eastern boundary upwelling regions, but also in western boundary upwelling systems. And one example here is the East Australian coastline, where in red I have marked regions where upwelling has been documented. And I want to show you some results of a case study we did here in the white area, the Byron Bay area on the East Australian shelf. So what we did there is we set out an instrument and monitored upwelling for a period of 4 months. And we used a high precision, but also a high frequency monitoring device, where you can see that then, for instance, seawater temperatures dropped, and this is an example of one event, dropped within a couple of hours by about 2.5 degrees during one of these upwelling events. That was accompanied by small changes in salinity, but most importantly, significant drops in pH by about 0.15 pH units, drop in oxygen saturation state by about 30%, increase in FCO2 by about 150 microatmospheres, and a drop in the saturation state of a very important calcium carbonate polymorph, aragonite, denoted here as omega aragonite, by 0.9 units. And if we look at the full 2-month record and the kind of upwelling events that are kind of a bit hidden here because everything is kind of squished together, when we then took the measured pH shown in black and extrapolated that into a pre-industrial setting, so how pH variability would have looked like in a pre-industrial setting when atmospheric and seawater CO2 was much lower, and extrapolated that into the future, here shown in the red line, for a year 2100 RCP 8.5 scenario. So how will these upwelling events look like in the future? And then also did that not for only pH, but also for FCO2 and omega. Then it became very clear that, for instance, here, if we look at omega, that we basically drop the baseline around which we have these oscillations. We dropped this, already dropped this baseline significantly from pre-industrial times to today, and it is kind of projected to significantly further drop when we move into the future. And in these dashed lines, I have marked several important omega aragonite thresholds, which I have listed here on the left, and I don't have to read them out all, but most importantly, obviously, is the aragonite threshold of 1. And when seawater, the saturation state of seawater drops below 1, then aragonite, the mineral, will basically start dissolving, which is obviously a problem for many organisms which build aragonite shells. And the highest threshold I've listed here is a threshold of 2.9, below which coral sediments basically transition to net dissolution, which is a problem for coral reefs if they lose their structural framework. If we look at these thresholds in our coastal setting, basically in pre-industrial times, none of these thresholds have been crossed for any of the time, or would have been crossed for any of the time observed. However, already currently, about 40% of the time, we are below a omega threshold of 2.9. And when we extrapolate it further into the future, then the two highest thresholds will be crossed by 100% of the time, and the lower thresholds will progressively be crossed. So it is becoming a big issue. So considering the natural and future pH variability, or also the variability in total alkalinity and dissolved inorganic carbon, ideally high frequency observations are necessary in comparison to a pre-industrial context to assess and project the ocean acidification vulnerability of coastal regions. And with that, I hand back to you, Trevor. Thanks.
Thank you, Professor Schultz. I think we have time for one question, and I would just like to ask you, for the benefit of the rest of us here, what kind of expertise and knowledge can Future Earth Coast as a whole offer for the people in Africa moving forward?
Yeah, that might lie with the coastal assessments, which is an integration that Patrizia already talked about. It's not only about assessing the physical and chemical state, but also, and biological state, but also having a strong lens on social, economic perspectives and problems and issues that come together with the environmental change. And those coastal assessments could be something that could also be deployed locally in regions in Africa that are of interest.
Okay, thank you. Great answer. All right, so I'm going to bring Peter Swazinski back up to the stage metaphorically to give his talk about some of the work that the OAICC is doing. After that, we're going to have a short 5-minute break where you can get up, stretch your legs, get some food, water, coffee, whatever you need. And then we'll come right back into a session about OA monitoring in Africa. It's going to be very interesting. We are a few minutes behind schedule, but I think we'll be quite all right, and still hoping to end this at 12 p.m. GMT. We might go a couple minutes over, but I appreciate your patience. And now, without further ado, Peter, I'm going to pass the mic to you. Peter, if you could just maybe introduce yourself a little bit for our audience members, say who you are and what you do.
Sure, Trevor, I would be happy to. Can you also share my screen?
Yes, you can share your screen now.
Excellent. All right, so welcome again, everybody. Most of you know me well already, but just a quick background. I'm on sabbatical from the University of California in Santa Cruz, and also from the U.S. Geological Survey in Santa Cruz, where I've been working as a chemical oceanographer looking at basically climate change impacts to coastal and marine systems, and have been a section head here in the radioecology labs in Monaco for 5 years, going on 5 years at the end of February. And here I'm really lucky. I have a fantastic team that is looking at basically climate change impacts involving coastal marine organisms. So we have a projects in the experimental laboratories where we look at ocean acidification impacts, we look at deoxygenation impacts, et cetera, and I'll touch on this in just a little bit. Many of you are close to the work of the OAICC, so I can run through this presentation relatively quickly. But I wanted to first start out by just mentioning that this work is done as a team. I'm one part of the team. Trevor is a JPO who has recently joined us, and we also have Carolina, who is part of the OAICC team, and I think she is online right now as well, and you guys will, I'm sure, get to meet her through various mechanisms. And then lastly, you all probably know Lena quite well, who was the architect of the OAICC in many ways, and she's now taken a job at the foundation next door to us here in Monaco, but we still have very strong ties to Lena and to the foundation, and she will still continue to play an important role in the implementation of OAICC activities. And what I'm supposed to talk about today is, let's see, capacity building on OA. And I think, geez, Sam touched on this really nicely, and I appreciated the kind of the larger overview on how things are changing in Africa, and I think it's very encouraging. So I'm going to run through my slides, and I think this will go quite well, so quite quick, so we will be able to end on time. So just one slide overview of the IEA in Monaco. I work for the International Atomic Energy Agency, and you might wonder, what would we be doing in ocean change work per se? Well, the Monaco labs have been here since the early 60s to address all kinds of marine affairs, especially related to nuclear and nuclear-derived techniques. And in the radioecology labs here, as it says, we use radio tracers to study lots of environmental stressors, OA, warming, deoxygenation, pollution. We have a big project on marine plastics and on harmful algal blooms. And what we can do is also do these things in multiples. So looking at the effects of multiple stressors, because we know that none of these things are happening in isolation. If you guys are interested, I highly encourage you to check us out online and then talk to us if you have interest in potentially working here for some of your work. The labs in Monaco are a little different than an academic lab, but we thrive on having a constant flow of new ideas in our labs. All right, so this is a graph that Sam already showed, and in my first talk this morning, I mentioned this important work by Jim Orr that came out in 2005. I think you can see this is at the beginning of this explosion in papers that have come out on OA, and it's not coincident. But just again to drive home that this is a relatively young discipline, and just over the last 15 years, there's been a tremendous amount of activity on OA, and since 2019, we have to update these numbers now, but more than 700 papers involving more than 2,500 authors. So lots of people are engaged in OA science. A quick overview of the history of the OAICC. At the Rios Plus 20 conference 8 years ago, the IEA launched the OAICC in response to increasing concerns from member states and upon recommendation of leading scientists in this field. And without getting into too much detail, the IEA, of course, is an expert and leader and promoter of nuclear and derived technologies. And for example, calcium-45 and also boron isotopes are really useful in assessing or quantifying the impacts of ocean acidification, both looking back in time and then current. Here's one way to portray kind of this broad brush outreach globally. This is a number of papers from 2006 to 2018, based only on the first author affiliation. And I think it's interesting if you do some timestamps here, you can see how various countries have and continents have gotten engaged in the OA science and oftentimes this is in response to large initiatives, such as, for example, in Europe on EPOCA and the METSI program, and some of you present today were leaders in, for example, of the METSI. There was bioacid out of Germany, et cetera, et cetera. So it will be interesting to see the work in OA Africa then that we can update this map to reflect more the work that's going on in Africa. So the OAICC functions on kind of 3 columns or 3 pillars. We work very much on capacity building, and some of the work that Sam had presented already is a direct result, at least, of co-participation from the OAICC. We work a lot on dissemination of OA activities on a global scale, and we are involved in directing and helping direct kind of the science, the frontiers of science related to ocean acidification. Our target audience is everything from students to scientists to policymakers, and we write everything from policy briefs to best practices guides on OA. And in terms of a toolbox, we have trainings at IEA through the technical cooperation program, but also what we do in our labs here in Monaco. We do trainings. People come in our labs, they learn how to set up aquarium, experimental aquaria, and then they can bring these back into their countries. We do mentoring, and there's a series of online resources and databases that the OAICC cultivates. Just as a mechanistic point of view, the OAICC is something called the Peaceful Uses Initiative project of the IEA, and we're very lucky that we've been the recipient of sustained and very generous pledges in the past that have allowed us to have this impact on global OA. And one of the most rewarding things for me personally is that I get to work with all of you on OA science. So, and I wanted to stress here in this slide, as has been mentioned before, this is only, we're only able to achieve these things through really fantastic teamwork. And I can say I've been doing oceanography for a long time, and I think we have something really special in the OA world. This camaraderie, this willingness to work together on all kinds of scales is something exceptional, and yeah, I think the achievements follow that. So I'm not going to go into each one of these. I will just mention that Monaco plays a particularly unique role in ocean science, and particularly in ocean acidification science. And I'll go back to this, our new brave ocean. If you had a chance to see this on YouTube, there was a very nice presentation by our Prince Albert II, who is probably one of the world's best advocates for oceans that we have right now. And I also wanted to mention that the most recent Ipcc Ocean and Cryosphere report debuted in Monaco in 2019. I'm going to skip this slide because Naira did a great job talking about GOA-ON, but it is one of the functions of the OAICC, and there is a secretariat, that tri-party secretariat for GOA-ON that includes both the IEA, NOAA in the US, and IOC UNESCO in Paris, and each one of those has a secretariat that participates in the coordination and implementation of GOA-ON activities, and Trevor is that for the IEA. I think this is an interesting slide again, and another way to document how effective we have been over these 8 years. Up to, I think by now we're more than 700 capacity building opportunities that have reached more than 500 scientists and close to 70 countries. And again, I think it's interesting if we do a timestamp on this to see how this capacity building has changed over time. I just have a couple more slides. One of the things I wanted to mention was Sam's leadership. We are one of the vehicles for the IEA to deliver is through a coordinated research program, and this particular coordinated research program is run through the radiology labs, and it deals with kind of the global impacts of OA on seafood. The OICC has its hand in a couple of things that I wanted to mention here. One of them is IOC UNESCO's role in SGD 14.3.1, which is the reporting process of pH measurements. We're involved with this, but then we're also one of the co-leads on a UN effort called Communities of Ocean Action, where we, in essence, shepherd voluntary commitments, keep them going, and kind of oversee and can report on these voluntary commitments. So with this quick introduction of the work of the OICC, please don't hesitate to reach out to us if we can help in any way. And I just wanted to toggle here back and forth. The first OA training in Africa was in 2015, and we've certainly come a long, long way in these last 5 years. Thanks very much, Trevor. Back to you.
Thank you, Peter. All right, I think we are short on time, so we'll have to forego the questions on this one, but why don't we take a break? We're going to do a 5-minute break right now. It's 11:37 CET. So why don't we all come back here in 5 minutes from now, and we'll get started. Get some water, get some food, go to the bathroom, whatever you need to do, and we'll get right back into it once we return. Okay, so I'm also going to step away for just a moment, and then I'll be right back as soon as possible. Feel free to, yes?
Just a quick thing. Tell us again the time you want us back.
Yes, please come back here at 11:43, let's say, and we'll get started at 11:45, just to make it a round number.
So not much more than 5 minutes.
Yeah, not much more than 5 minutes. We'll definitely be starting at 11:45. Okay, you won't want to miss the next talk, so enjoy your break, and we'll be right back. Welcome back. I made it. 11:43. I'm impressed. Falilu, you're back. How's it going? Oh, 1 sec. Looks like you got a nice breeze in your house. Here, hey Falilu, I'm realizing your microphone is not connected. You got to go to audio and video settings and then click speaker and microphone settings. You can select, there we go. I see you now, microphone icon. I'm unmuting you.
Can you hear me now? Can you hear me now?
Now I can hear you.
I was just trying to connect to the audio. I don't know, but I can hear you now. Yeah.
Good.
The meeting has been going on very, very interestingly and very successful.
Thanks. Do more of these, formal like this and more informal as well. Just ways for all of the marine scientists, the ocean acidification researchers to connect across the continent. It's a big place, and there's there's a lot of opportunity for this. So I'm glad you're enjoying the event. Is everyone back? How are we doing? Let me know. We got the next talk coming up.
Yeah, Trevor, I would think we should start going again.
Yeah, let's start it up. Okay, 1 second. Edem, are you there? Okay.
Yes.
I'm gonna ask you if, okay, Edem Mahu is a lecturer of biogeochemistry at the Department of Marine and Fishery Sciences of the University of Ghana. Her research interests span geochemical cycling of elements with the land-sea interface, marine environmental pollution, ecosystem connections, seafood, and of course, ocean change. She's also a trustee of the Partnership for Observation and Global Ocean Acidification. And she's won a lot of recognition and other distinguishments that I do not have time to mention, but I'm very happy to introduce her, and I'm passing the mic to you now. Okay. So you can share your screen now.
All right. Good morning, everyone, and thank you very much for inviting me to this very important event. I'm very happy to be part of it, and more importantly, to share with you what the initiative that has been started by the Partnership for the Observation of the Global Ocean on Ocean Acidification in Africa, specifically the Gulf of Guinea. Yes, we are all aware of the changes that our oceans and our coastal ecosystems are, witnessing as far as ocean acidification or ocean pH is concerned. We are all aware of the devastating impact on ecosystems and species.
that dwell in this environment. An understanding of these changing acidity on coastal ecosystems, we believe requires a globally coordinated effort. And at this point, we really want to appreciate the effort of the Global Ocean Acidification Network, the Ocean Foundation, OA Africa, and then the International Ocean Carbon Coordination Project. And many of these efforts that are ongoing. We also understand that efforts to monitor OA in the Gulf of Guinea mostly have focused on human capacity development. So we have quite a number of scientists who have benefited from some of the capacity development initiatives that our previous speakers have spoken about. But we think that we need to take some of these things or some of these steps a bit forward. And so we had a discussion with the Partnership for Observation of the Global Ocean. And through this discussion, OA, or ocean acidification, was one of the issues that we talked about. That it's an area that West Africa is lacking, expertise in terms of, measurement, monitoring, and all that. And so we started a working group in ocean acidification in the Gulf of Guinea, and we call this the Building Capacity in Ocean Acidification Monitoring in the Gulf of Guinea. The goals of this group, we are not trying to reinvent the wheel, we just want to continue and consolidate the efforts that have already been started by all the organizations that are working in this area. And we are very happy to be partnering with some of these organizations. We started the partnerships already, but we hope to, get to work with more of these organizations. So the goals are, first of all, to develop a coordinated network for observing OA in the Gulf of Guinea. We want to be able to develop capabilities to undertake analysis and measurements of seawater OA chemistry parameters. We want to map out OA hotspots in the biota member countries for long-term OA monitoring. Kai mentioned the eastern current upwelling regions, and the Gulf of Guinea actually happens to be one of these areas, and so which has intense upwelling, and we are hoping that through this biota effort, we can really come out with some of the hotspots and areas that need OA monitoring in the long term. We also intend to initiate OA monitoring activities in the biota member countries. And then we also plan to integrate this network into global OA observing networks like the OA Africa network and then the GOA-ON network. I'll talk briefly with you about some of the things that the group was started, or the working group was started in September 2020, so it's quite new. But we have started working, and so first of all, we have been able to develop a network of 7 countries in the region. And the good thing is that the network was actually developed from the existing GOA-ON network. And so far we have 4 POGO members, and we have 3 non-POGO members who are part of the network. And so this, for now, are the countries that we are going to start this biota project with. In terms of partnership, as I said, we plan to, have partnership with organizations that are working to address ocean acidification, to bring understanding into the impact of ocean acidification. And the Ocean Foundation is one of such organizations. We have been talking with them through Alexis, and we have been able to come out with a partnership with the Ocean Foundation. And so we will be, Biota will be working with the Ocean Foundation as far as capacity development and also support for equipment and other things are concerned. So just to, highlight some of the things that the previous speakers talked about, we also want to understand the status of OA monitoring in these countries. When one of the speakers actually mentioned that, you can start with something. You don't have to say that because I don't have any equipment at all, I cannot start monitoring OA. So we've started a Google survey where we want to understand the status of OA monitoring in these different countries, what in terms of parameters, what they are already monitoring and what they would have to start now that they are part of this network. In terms of capacity, what they already have there. And so once we have all this information, we are in a better position to know how to allocate capacity building needs and also resources to the various countries. Patrizia talked about, the social implications of ocean acidification and all that. And so communication is one of the key programs of this network. We want to, with time, be able to communicate ocean acidification impact, progress and all that to the lay community, the fishermen, the government institutions, and all the key players that can form part of these problems. And so communication is one of such things, and we did a press release on the OA Day of Action just to initiate or sort of advertise the Biota network to larger communities. Now, there are other things that we are yet to do. We plan to have an in-person or a couple of trainings that are scheduled to take place between February and March 2021. And then after these trainings, we are hoping to start OA monitoring by June 2021 in the Gulf of Guinea. I would, at this point, ask for expert support. If we'll be sending out emails anyways to some of the experts who have already presented in this meeting to share their experiences and also to help in the training sessions that will be starting shortly. So thank you very much. And any questions, or if you are interested in joining this effort, you can send an email to me, or you can contact the POGO Secretariat for.
Okay, great.
Thank you.
All right, and why don't you write to everyone in the chat the link for the POGO Secretariat, just in case they do want to contact you after the event.
Okay.
And let's see how we're doing time. Okay, so I think I have time for one question, and I just wanted to know from you if you can describe some of the parameters you're looking at measuring in the Gulf.
Yes, so it's basically the usual OA parameters. So for now, we are looking at discrete measurements. So going to take water samples, and then we come to the lab and look at pH, look at total alkalinity, dissolved inorganic carbon. Basically, yes. So these are the parameters that we are looking at starting with. And the Ocean Foundation has actually given us, that assurance that they will be supporting with some equipment. We are yet to come to agreement formally with what sort of equipment we are getting, but it's likely that it's going to be the GOA-ON kits.
Yeah.
In a box kit, yes.
So some discrete measurements from cruises, and hopefully some maybe an ICME that could be deployed. Perhaps.
Yes.
Is that right?
Yes.
Okay.
Can I make a comment, Trevor, or do we don't have the time?
Go ahead, Sam. Why not?
Thank you. So thank you for this presentation. It's really exciting to see some new projects starting like this. And I think something that I will write to you, but something very important is to realize that monitoring won't solve a thing, except if you really do it well, in the sense that I think Kai mentioned the importance of the resolution on the coastal zone. And I think actually if you want to gather information that can be useful for addressing at the societal level, you will need to have a biological thinking. And if you don't incorporate that from the very beginning, the data you're going to collect, that's not going to be very useful for the country. I think it's a really important first step, but I think you have the chance of starting it exactly right. So how many times you need to sample, where you have thinking about it, but the frequency and for what purpose. I think if you just collect data for the sake of it, that's not going to be very exciting. But I will write to you. I would be interested to help if you want in thinking about those aspects. But nice work and good luck.
Thank you very much, Sam. I actually intended to write to you also, so please expect an email from me. Thank you.
All right, we're going to move on now. I'm going to play a recorded presentation that was put together by Carla Edworthy. Unfortunately, she couldn't join us today, but she took the time out to make this presentation, and there'll be no follow-up, of course, but we will, her email is there, and so you can write to her if you have any questions. Okay, so I will share my screen 1 second. All right, please enjoy.
Trevor, no sound yet.
No sound? I'm sorry, the sound works on my end. Does it work? Peter, can you hear the sound?
No.
No, I can't.
All right. One second. I'm just going to try restarting this. Okay. How about?
No, it's not working yet.
Can you hear it now?
No.
All right. Unfortunately, I don't think we'll be able to play Carla's talk, but I'm going to make it available to you all on the OA Information Exchange afterwards. And I'd highly encourage you to check it out because it is very interesting. And Carla is an impressive researcher who's got a lot to say about this subject. Okay, so we're going to move on to our next session now. One moment, please. We're looking at the status of OA in the African region. And we know that capacity building and monitoring efforts are really designed to spur more scientific research to inform science. And in this session, 3 impressive scientists will give you a sample of their new findings and results from across the continent. They'll be sharing their research efforts in Northwestern Africa, the Gulf of Guinea, and the Southwest of Africa. So now I'm going to introduce you to Adekunbi Falilu, who's a graduate student in the Department of Marine Sciences at the University of Lagos, Nigeria. He is a researcher at the Nigerian Institute for Oceanography and Marine Research. The focus of his PhD project is focused on the synthesis of data to characterize dynamics of seasonal coastal ocean carbonate system and ocean acidification off the coast of Nigeria, Gulf of Guinea. Okay, so Falilu, you now have the mic. Go ahead and share your screen with us and start the presentation. Everyone else, make sure your mics are muted.
All right. Thank you very much. Can you all see my screen now?
It's loading. 1 second.
Okay. Okay. Just a minute, please. Okay.
All right, there we go. I see your screen. Go ahead and present. Go ahead, presenter mode.
Just 2 minutes. Okay. You're all welcome to the webinar on the promoting ocean acidification.
Falilu, could you put it in presenter mode? I'm sorry, we see for the PowerPoint.
Yeah, I just did that. I think it's
okay. It's probably just lagging. Sorry, go on.
So, okay, do you see it now?
Yes.
It's okay now. Okay.
Yes, it's okay. It's great.
Yeah. Yeah. Thank you very much. I'm Falilu. I will be presenting on developments on of OA in the Gulf of Guinea. The global ocean covers about 70% and absorbs about 1/4 of the anthropogenic carbon dioxide. It plays a regulating role in Earth's climate and biogeochemical processes. The ocean faces a number of challenges, including pollution, oxygen depletion, and in the last decade, ocean acidification. Geographically, the Gulf of Guinea is located in the eastern equatorial Atlantic between Cape Lopez and Cape Palmas. The region is rich in fisheries resources, marine fisheries resources, which supports the livelihoods for the teeming population and also provide foreign exchange earning for the coastal states. However, the Gulf of Guinea is subjected to a multiple factors that places risk on the marine resources. Among these challenges would include population growth, fisheries depletion, loss of biodiversity. However, the state of knowledge related to ocean acidification dynamics and its impacts in the region is completely lacking. Hence, there's a need for evaluating ocean acidification in the region, such as that of the collaborative initiative that has been brought about by the OA Africa. Considering the status of OA research in the Gulf of Guinea, in spite of the fact that the region is an important area for equatorial dynamics, for CO2 equatorial dynamics. And again, it's well situated to better understand OA and its consequences on coastal ecosystem, basically because of its seasonal coastal upwelling, which occurs in the northern Gulf of Guinea. But then, unfortunately, there's a scarcity of carbonate system data, especially in the coastal environment. For instance, countries like Nigeria, Ghana, Benin Republic have no data on monitoring. They have no data or any program on monitoring of oceanic CO2. This is very evident in this FCO2, global FCO2 distribution by SOCAT. It's evident that the Gulf of Guinea, there's a data gap in that region. Hence, there's a need to further look into how we could get more data to be able to characterize the CO2 system for OA. Now, CO2 parameters within the equatorial Atlantic studies are very, very few. But one of importance is that by Kofi et al. In 2016. You could see that within the equatorial Atlantic, dissolved inorganic carbon is majorly controlled CO2, which evolved from upwelling due to bringing up of high dissolved oxygen bottom waters to the surface. If we look at alkalinity within the equatorial Atlantic, we see that alkalinity follows a direct relationship with salinity. And that is the reason why if you see the normalization of alkalinity shows that that parameter is majorly controlled by salinity. Basically because in the upper Gulf of Guinea, there's freshening from rivers, which lowers the alkalinity. But then in the lower, in the southern part of the Atlantic, we have high alkalinity because of less freshening and high salinity. The monthly air CO2 flux in the region for the equatorial Atlantic is when we look at the trend, you see that basically during the boreal summer, that's when we have higher level of CO2, probably because of upwelling. Now, amongst the areas which we will need to assess is the vulnerability to carry out the vulnerability assessment of the fisheries resources. Shore fisheries is a major holder for the region. So there's a need to understand what is the response of all our shore fisheries resources to OA. This we haven't been able to do at all. So we need to work more on that. I would like to talk briefly on to talk on the overview of activities of the OA of OA Africa within the Gulf of Guinea region. Most importantly is that of the Blue Ocean Conference, which took place in 2019 in Monrovia. The conference contributed to raise awareness of ocean acidification within the region. So we had a lot of participants who came to really have a better understanding of what OA is all about. Now, for the we are presently carrying out we've carried out a compilation of a white paper which highlights the knowledge and these recommendations on how we could advance OA research and awareness in the Gulf of Guinea. This document is ready and should be put to the public, published very soon. Now, on capacity building, a lot of capacity building, a few rather of capacity building has taken place. One of those important ones is that by the peer-to-peer, and then that done by the GOA-ON, especially for the one-to-one coaching session that was given to participants at the coaching summer school. So now, a few recommendations, like I said, is to bridge the ocean acidification data gap in order to be able to anticipate the economic and social impacts of OA on the marine ecosystems. Another very important area is the strengthening of the involvement of scientists from the region to commit to play active parts in the network. And finally, the OA will play a leading role in soliciting for funding to support regional OA research and outreach activities in the Gulf of Guinea. I would use this time out to appreciate all the organizations that have taken, that have, in one way or the other, have helped to support capacity building within the Western African region. Of course, I would also like to give thanks to every member of the OA Africa. Thank you.
Falilu, thank you so much. Really appreciate you taking the time to give this presentation. And we do have time for questions. So I'd like to ask you, why should governments invest more in ocean CO2 monitoring, like in the Gulf of Guinea?
Yeah, there's a lot of reason why there's a lot of need for investment. The climate change challenge within the region, there's a shortage for fisheries resources, the shell fisheries importantly. The local communities don't really have good supply of the shell fisheries. Basically, one of the ecological challenges is likely to be perhaps maybe OA that is working in synergy to maybe ocean warming. So the government needs to really probe into what is the state of OA in the region to be able to ascertain how food supply could be available to the people, the population. Okay,
thank you. You're studying the Gulf of Guinea, so tell us what's so special about the Gulf of Guinea. Why is it? What are some interesting oceanographic features of the bay with respect to ocean acidification?
Yeah, thank you. The most interesting oceanographic feature in the Gulf of Guinea is the seasonal coastal upwelling, which occurs within the boreal summer, that brings up high CO2 from the bottom to the surface. There's a need to really understand what this dynamics has on OA.
Thank you. And any future directions for research or scientific questions you're interested in?
Come again?
Do you have any future directions or scientific questions that you're planning on investigating after?
Presently, I'm undergoing my research, and my research is basically to look into what is the role of high CO2 on the key marine plankton. So for now, that has been my preoccupation. So I look forward to having an outcome which could be used for future recommendation within the region.
Thank you so much. All right, we're going to go to the next talk now. Dr. Mohammed Idrissi is an oceanographer, a researcher at the National Institute of Fisheries Research in Casablanca, Morocco, and works on topics ranging from geochemistry to sediment dynamics to physical oceanography. Mohammed, I'm going to pass you the mic. You can now share your screen with us. I've also unmuted you. Mohammed, are you there? Trying to unmute you. Okay, we seem to be having some connection difficulties here. There we go. You hear us?
Trevor?
Yes.
Trevor?
Yes.
It's my turn, right?
Yes, it's your turn. Go ahead. You're muted, Mohammed, by the way. Try and unmute yourself. Mohammed, could you unmute yourself? Okay, it seems like we're having difficulties. What I'm gonna do is, Mohammed, if you don't mind, I'm gonna move to Chibo and then we'll come back to you. And hopefully your connection will be better established, because right now I can't unmute your mic and the content's not loading well, but that's all right. We're gonna come back to you. Chibo, are you there? Hey, can you hear me? Yes, great. I hear you.
Yes, I can.
Would you be willing to introduce yourself and present to us?
Yes, but you need to, like, I can't share my screen yet.
Yes, you should be able to share your screen now. I've made you the presenter.
Not. I don't know why. Everyone, my name is, and I'm a marine microbiologist that works at the University of Namibia, and well, we're situated in Henties Bay. And this is not cover. The share button is not. It's not letting me pick.
There, it's I just am gonna give it back to you again, and maybe that will reset it for you. You should be able to present. If you go down to the share right next to your stop.
I'm clicking on it, but it doesn't
not
show me. It says that there should be system preference.
Okay.
So it doesn't actually let me select the files.
That's all right. What we're gonna do is you sent me your presentation, yes?
Yeah, I put it in my Dropbox, so just download it from there.
Okay.
The link yesterday. What's wrong with me?
Could you send me that link? Hello?
Hello. Yes, I'm so sorry. Can I get? Can I share my presentation now?
Chibo, if you could, yes. One second, Mohammed.
Let's just
1 second.
go to Mohammed.
Let's go to Mohammed, and then Chibo, can you send me that link again? Because I don't see it in my inbox.
Okay.
So send me it, and I can load your presentation from my computer if it still doesn't work. All right, now, Mohammed, we're back to you. I'm going to send you the mic again. You should now be able to present. Great. All right, we see your presentation. Go ahead and
It's good, right? You can see me, right?
Yeah.
Okay. So thanks, Trevor, and I'm happy to be with you guys, all of you today. And it's great to have this follow-up of OA Action Day, which was held on January 8, 2021. In this presentation, I will present the study of ocean acidification in the Northwest Africa, Atlantic, from Morocco to Gambia with the new funding. And because we don't have a lot of time, so we got a lot of diapositive from the result. And with the involvement of different teams from Morocco, from Norway, from Mauritania, from Senegal, from Gambia, and from Monaco too. So, as you know, the Canary Current large marine ecosystem, CCLME region, supply very significant fish resources based largely on small pelagic fish. This fish market contribute to the economy of the country. This country is bordering the sea and provide an important food and employment to the coastal communities. In 2017, the 30 years long EF Nansen program, FAO and Norway began with the studies of ocean acidification along this region. And here with this program, we will show the first result on ocean acidification state as a baseline from this new research program. But before I go through this, I'm going to present an overview of the study of the Team 10 of the EF Nansen program, which all this research project are under as a funding of our projects. And secondly, I will go with the study of OA and with some result at the end for Northwest Africa, Atlantic coast. For the lead of this team, it's Melissa Chorisi from Norway, with the principal partners from Africa. They are especially from Atlantic and the Indian Ocean, not from the Mediterranean. So the main partner, it's EA from Monaco, Peter and Biat, and other partners like Dr. Patrizia Ziveri, and with the key personnel from Norway, David Cervantes and Helen Hubal Lodmel from AMR. The science plan team of EF Nansen program have three main research areas, and in turn they are subdivided into a total of 11 teams. And the Team 10 is under the main research of climate change and the climate change impacts. So the objective of the Team 10 is to establish the baseline values and surveys in surface water and water column to assess changes in the chemical environment and changes of the ocean, such as oxygen concentration, nutrient, ocean acidification, marine CO2, system pH, and the other derived parameters such as PC2, Aragonite, and etc. And we are focusing on, especially on the oxygen minimum zones, like low pH areas, on also upwelling systems, vulnerable benthic habitat spawning areas, and coastal areas with large fishery influence with relevance of sustainability. In February 2018, more than 60 scientists from 10 countries participate in this meeting, and from here we got, especially for the Team 10, we came up with six projects. The first one is for the variability of oceanification state and CSA water saturation. Then the second, the driver and trend in OA oxygen nutrient. The third project is the value construction of low oxygen event. The fourth, carbofluxes in OMZ biological carbon pump. And the 5, Congo River prime dynamics. And this project number 6, the role of the dust on primary production and oceanic CO2 uptakes. And this project are funded by the AF Nansen program under the Team 10. And I think all African countries, especially partners countries or partner institutions, are involved. And so please, if anyone want to get involved in this project, just can contact me, or anyone are involved like Peter or Chibo or anyone here like Sheikh too. After the meeting, just like a little bit, so we find out that the most scientists need training and improvement protocols for good data and good science. That's why we did start this training. The first one was on Cape Town, January 2019. The second was in Dakar, Senegal, September 2019, all two. And all this just for improve the protocols and quality checks on the data. And it's still continuing, of course. And also the data set and compilation workshop, like the last one was in Tromsø. And all the time, CTD Lab team leader spend 90% of the time of teaching of the rest of the scientists. So for this area of the Northwest Africa, the oceanographic cruises cruises were carried out on the board of the research vessel Dr. Fridtjof Nansen along the Northwest Africa from January 2017 to March 2020. So far, we have done 2 surveys. They are complete surveys from North Morocco, Cap Spartel to Gambia with 2 complete surveys. And these surveys, we are focused on water parameters such as ocean acidification, pH alkalinity, dissolved oxygen, salinity, nutrient, chlorophyll A, and also we collected the data, temperature, salinity, dissolved oxygen from the CTD, and we are talking about the whole Cannon water here. And this, hold on, please, and this include, this include the one mesopelagic. We call it one. It's long transect. We call it mesopelagic transect, which we did twice too in 2017 and 2019. For 2020,
I need to ask you to wrap up in a few minutes.
Yes. And for the 2020, we had just 2 surveys in Morocco, Atlantic coast from Cape Spartel to Cape Blanc. There in the first survey, we did the same parameters and we add some sediment from the Grab Van Veen. And for the second survey in Morocco, we did the same parameters for the water, we are focusing the same for the project 3 and the sediment, such as the sediment from the box cutter for some trace metal, radionuclide, datum, diffraction, and sediment for the Grab, the Van Veen too. So for each station, the parameters of temperature, salinity, chlorophyll A, density, and all this parameter will carry out spontaneous from surface to the bottom of the water column with CTZ sound. Also, the total calinity was analyzed using the potentiometric titration. The pH was analyzed too, and other parameters describing the carbonate chemistry were derived from the alkalinity and pH using the CU2 CIS calculation program, and the macronutrients was analyzed by using the autoanalyzer. And in conclusion, for 2017 data, we found large variability. Just based on 2017 data, we found large variability along the coast connected to salinity change, primary production, temperature, and biological process. In fact, this measured parameters, pH, alkalinity, coincide perfectly with the physical parameters, and while calculated parameters inversely varies. This result will present the first ocean acidification data from Northwest Africa and must be discussed in the context of deep water intrusion, salinity changes, temperature, and phytoplankton production. Just give me 1 minute, Trevor, and I'm done. For more for the science plan for this program and this project, we still continue the data collecting and quality checks, get nutrient data and oxygen in. We are going to combine 17, 19, 20 data set. Then we put this last year from the January 2020, 2 PhD students of this project program. They are linked to the project 1 and project 3. The first one studying ocean acidification and its impact and upwelling zone of the Moroccan Atlantic coast. The second PhD program is the paleoconstruction of the low oxygen event in the Moroccan Atlantic Sea. And we have this year 3 master students in this program. For the sub-manuscript and publication papers based on the data from 17 to 20, we have some of them, they are finished, and other they are in preparation, like the last one, coral reefs, habitats of the West Africa, with the environmental setting. And Edem, she's here, we are in this place, we are going to include Ghana too. So she's with us in this work too. And some conferences, unfortunately, are postponed because of the COVID-19. It was programmed for, we have like 7 presentations for conference. They are postponed to 2021. And we need to find out scientific expertise to work with the data and lead publication for each region. When I say each region, I'm talking about the Gambia and Senegal, Mauritania, and and Morocco. And thank you, Trevor. And I'm back to you. Thank you.
Okay, thanks, Mohammed. Fortunately, we don't have any time for questions now, but what we're going to do is be following up on the event. I encourage everyone here, all the attendees and the panelists, to join us on the Ocean Acidification Information Exchange Team Africa, or OA Africa team, to continue the discussion. All right, so now, Chibo, are you able to try again? Yep, go ahead, Peter.
Did you get my link?
No, I did not. I'm sorry.
Following Mohammed's presentation, I just wanted to let everybody know that we have a special issue of environmental pollution that has been just opened up, and looking for papers on seafood safety, climate change impacts. If you guys want more information, please let me know. Thanks.
Okay, thanks, Peter. I did not get the link, but I'm going to try to make.
Can you check in your junk folder, because it was sent through OneDrive?
Okay, I'll check.
Yeah, sometimes I get chucked into the junk folder.
Yeah. Looks like it's, I see your introduction. It's not showing up. Can you try and presenting it on your computer again? I'm going to pass you the link because I see your video, so hopefully it's working.
Yeah, but like the share option is not working, and I'm not too sure why. Because under privacy, I mean, I'm supposed to be able to share my screen.
I'm sorry, the security features of the IAEA, which are rather aggressive, have disabled the link, and I can't actually see it, what you sent me to my IAEA email. That's what happened. It is in my junk.
Okay.
That's a shame. What we could do is, yeah.
Is there any way that you can get it on your personal email and show it that way?
Yeah, if you could send it to my personal email.
Can you type it at the bottom, please?
Yes, I'm sending it to you personally. Okay, I sent it to you.
Sorry, everyone. This is my fault.
Anytime.
Or maybe Mohammed can elaborate on his last slide.
I actually do have a question for Mohammed. So while you're sending it to me, let's do that. All right, so.
Yes, Trevor.
Yeah, Mohammed, what are some research questions that you would like to see addressed relating to the survey you've conducted between 2017 and 2019?
So for the old data, we're still working on it. So we just finished with the last 17, it's done. So we did like everything. We finished with the data and post-processing and everything. So we have the result already, and we presented some places, like some conferences. We are still working on the 2019 for the post-processing with the 20. Unfortunately, we at March 2020, we stopped the survey because of the COVID-19. We were in South Morocco. We were going to finish at least the Northwest Africa, and to get the time series at least for 3 times, like 17, 19, and 20. And for the Morocco part, we're still working on it. With this year, we just start doing the same transact with our vessel. We get the same transact from the Nansen program, and like that we can keep going, do the same thing and get time series for the OA program, for ocean acidification program.
Okay. Nice. But can you tell me a research question or like a hypothesis that you could ask the data?
I didn't Can you
Sorry.
repeat? I didn't understand your question.
Yes. Could you tell me a research, like a hypothesis that you might be asking the data? Like what would be a interesting research question that you could ask the data that you have?
Yeah, we will see this with this both all projects. They are we are going to relay on this repeat station section and historical data with the physical oceanography, and at the end see what it's gonna give us for the baseline observation of OA. So because we just start doing it in 2017, so it will be let's say the baseline of OA data in this region.
Okay, I understand. Thank you. Chibo, were you able to send that to me? I haven't seen it in my inbox.
You should have it now. I sent it 5 minutes ago.
To my personal email?
Mm-hmm.
Okay.
Check your junk folder again.
Edem,
Yeah, I'm checking.
صيفط لي مساج. وكو صيفط لي مثلا إيدم.
For whatever reason, it still hasn't showed up, unfortunately.
Trevor?
Yeah?
I make a suggestion that maybe we move on to the panel discussion because we're just 20 minutes. And then at the end, maybe if we have some time, Chibo would be able to make her presentation.
Okay, let's do that. All right, we'll do that, and hopefully, if you were to write out the link but deactivate the hyperlink, for instance, so it doesn't recognize the text as a link, you could send it to my work email. We could try something like that, or if you had a PDF that you could share with me, that would be. I asked for the presentations in PDF or PowerPoints. If you could send me that, it will go through.
Okay, I'll try that.
Otherwise, what we're going to do now is we're going to start our panel conversation between the OA Africa co-chairs and Peter. So I'm going to welcome you guys all back. Now, just as a reminder, we have Nayrah Shaltout, Sheikh Sharif, and Roshad Ramasu, along with Peter Swazinski, who are going to be having a conversation about the future directions of OA research in Africa. They're going to be talking about some of the review that they've done in their region and working on some important white papers that we are finishing up in collaboration with the IAEA, and what recommendations they have going forward. So hopefully you guys are ready. I think you need no introduction, but let's see, Roshad hasn't spoke, so I will say Roshad Ramasu is an associate professor in ocean and coastal sciences at the University of Mauritius, and currently a co-chair for the OA network. His research interests are focused on marine biology, geochemistry, and ocean acidification, and he's led a variety of projects for organizations like the U.S. State Department and the Ocean Foundation. Sheikh is a PhD candidate at Queen's University Belfast with a background in marine research and management resources, and he's been working across a wide range of governance, conservation, development. Naira, you've already heard about, and Peter as well. So let's get this started. What we're asking, the format of this event is each panelist is going to give a short statement of just a couple minutes summarizing their findings for their research. Please try and keep it short because we want to be able to have time to ask you questions and allow conversation between the panelists. I ask everyone else to please turn off their video because we're just going to feature the panelists now. So only the panelists with your video on, and I will turn off your video if you haven't done so already. And I will turn off my video as soon as I finish explaining that the panelists are going to be answering questions. Try to keep your responses to under a minute. Peter, you're all, and all of you are also welcome to ask if you can pose a question and to steer the conversation. And the goal of this is that each of you are going to conclude with a final short statement, sort of an executive summary of where you see the direction of ocean acidification research, especially capacity building and monitoring, going in your regions and in Africa as a whole. So that is our panel format. Without further ado, let's start with Naira. Naira, if you want to give us your executive summary of the white papers you've been working on.
Okay. Hello?
All right, you're unmuted. We can hear you.
Okay, sorry, I didn't hear you well.
Go ahead and start by giving a brief summary of the white paper you've been working on. And then we're going to go around. Each one of you is going to give a short synopsis.
No. Africa.
Yes.
Yes, okay. During the last 2 or 3 years, we, as chairman of Ocean Acidification Africa, in collaboration with IEA, and in all the support of the mentors, Sam, Dupont, Patrizia Ziveri, for working and preparing of Ocean Acidification white paper for North Africa. We tried to collect data for the previous research data and the previous history of pH and carbonate, available data for carbonate for North African countries, coastal water in Mediterranean Sea. Actually, we put the data for the baseline data, and we worked for the analysis of this data, the types of the commitments that govern the ocean data, and how to analyze these data, to analyze the impacted species biodiversity, to highlight the highly vulnerable areas, and to have an overview of the pH decrease since the pre-industrial era, till nowadays, till 2020. Also, our colleagues in Tunisia are working for the international governors for the Mediterranean. We are working now for the collaboration between the North African countries for how to move needs and what we gain, what we have, what the needs for North African countries, and for evaluation the available data. And it's expected to have a first draft after 1 month. Okay.
Okay, thank you.
You're welcome.
Roshan, why don't you go ahead?
Okay, thank you, Claudia. So, well, we started working on the white paper probably 2-3 years back, and we had a number of resource persons like Sam, Dupont, Kirsten, SNC, individual Mark Spalding, most, and also the principal investigators who were funded under the WAMSA IOC UNESCO project. So we've been updating and working on this white paper for quite some time. And obviously, each of our principal investigators in the various 6 countries wrote descriptions of the problems facing the East African coast, especially in Seychelles, in Mauritius, in Mozambique, in Tanzania, in South Africa, and in Kenya as well. So this is how we started all. And so we kept updating, and obviously there's a new platform, the science platform, which needs to be updated and to create this science policy platform. And hopefully in February or March this year, we're going to present a white paper based on some of our findings. And just to be very brief, so that we found that the ocean acidification, as everyone knows, is a profound change in ocean chemistry as a result of anthropogenic carbon dioxide. And without rapid science-based action, the consequences of OA on marine species, ecosystems, associated services, and peoples depending on them will be dramatic. And we see that the ocean acidification has consequences for the Western Indian Ocean region. And we also recognize that it's a major threat by the international community. And therefore, most of the projects that we've been working on, these are pilot projects funded for starting March 2019 and probably finishing probably December 2021, involving both carbonate chemistry and biological experiments. So we're trying to see that the local and regional data are needed to develop and implement adaptation solutions. And obviously, we need to prioritize OA research towards short-term solutions. And we also see that ocean acidification, as again been highlighted, that we have less publications, very low. So it's still still in its infancy, and we need to do small-scale regional projects, which are already documenting the impacts of ocean acidification. These are things that are happening over the last 5 years in the East African region.
Thank you.
Yeah, probably just 2 lines. So we believe that the Nairobi Convention can assist us, and this will promote national and regional solution-oriented research. Thank you.
Very good. Check. Here, you're muted, Check. 1 second.
Good morning, good afternoon to every one of you. Well, the white paper, as the rest of my colleagues, panelists just mentioned, started a couple of years ago. And the essence or main objective was actually to help readers, stakeholders, partners, or well-wishers to understand the issue of ocean acidification, help to address the challenges it poses, but also help to make decisions to ensure that we reduce the impacts. I would like to make special reference to the support to Falilu of Nigeria and Professor Patrizia Ziveri, who both were very instrumental in helping to support the drafting, the complete draft of the white papers. There are a couple of other authors that are not currently on the score, and the paper has gone through 2 reviews already, and we are still looking forward to working with the rest of you and our partners to finalize the paper. Just in summary, the paper is actually focused on ocean acidification activities in the Gulf of Guinea. And the Gulf of Guinea, as you heard from Falilu's presentation, covers 14 countries, and from Liberia, ranging from Liberia to Angola. And Falilu spoke of the seasonal coastal upwelling, which is very essential for fisheries production. There are over 1 million people that reside within this area cover, and most of those people or residents or coastal countries are dependent on fisheries for their social or economic development. Again, the decline in ocean pH, which we also refer as ocean acidification, is a major issue, and this is why we are here today to discuss a collaborative or integrated approach in addressing the issue. And now the white paper, besides looking at the background of ocean acidification and highlighting those issues of ocean acidification from local to global impact, but also highlighting social economic impacts, which has often been overlooked, but not only affecting communities, but more of a regional scale. It was also important that our paper looked at the framework conventions and agreement, which is very important, because without any legal or superseding legislation, it is almost impossible to address these issues, because governments We have support, of course, from partners, from the Ocean Acidification International Coordination Center, part and parcel feature, of course, and the Ocean Foundation, but that is not sufficient. The government has to take ownership and leadership on this. And in order to do that, it is important for governments within the Abidjan Convention region or the Gulf of Guinea area to ensure that framework conventions and agreements are adhered to or signed and ratified. And speaking of framework convention, we too will talk about the United Nations Convention on the Law of the Sea, the Convention on Biological Diversity, the United Nations Framework Convention on Climate Change, regional agreements like regional fisheries agreements or other relevant agreements within the region, which the white paper on West Africa went into details. Looking at, in summary, priority area for capacity building, it is important that we stress the importance or need for ocean acidification data. Without the data, it's important to note that there is not much to be done. It is almost going to be impossible to close these gaps, as we saw from the presentation sought out by Sam Dupont. So ocean acidification data is scarce in most developing regions, but there are a couple of issues responsible for that. Basically, looking at West Africa, we lack instrumentation availability, and that is basically for the wider Africa region. Yeah, it's important that I know that West Africa has been the least supported in terms of capacity building, whether technical, financial support or capabilities, and we will hope, after some representations here today and after publication of excerpts from the white paper, West Africa will also be considered a priority area as much as North Africa and the Indian Ocean region is being considered. So just to yeah.
Could we have to keep going. I'm sorry, Sheikh. Could you just finish what you were saying?
Yeah, so for data, it is important to know that we need data. We heard from Bauta and Edem Mahu, need data on temperature, salinity, oxygen, pressure, of course, looking at the depth, the carbonic system constraints, looking at pH, the partial pressure of carbon dioxide, total alkalinity, and the rest of the ocean system constraints. So future direction, we're talking about developing time series ship-based hydrographic cruises. We're looking at training workshops, but also building regional capacity because the African continent is bounded on the western margin by the Atlantic Ocean, usually connected to the Pacific. So I will stop here for now, and we'll look forward to the discussion. Thank you very much. Okay.
All right. Peter, you've been involved with the white papers from the beginning. Maybe you could just briefly state your role and what your aspirations for these research endeavors are.
Yeah, I would be happy to. I actually wasn't involved from the beginning, but I've been watching it closely. I just have a couple of comments. First of all, on the white papers, and then also maybe some possible opportunities looking forward. And I guess as the three leads of the three different regions in Africa have just shown you, there are differences that are worth noting. So there are physiographic differences, there are socioeconomic differences, tying back down to Patrizia's talk. There are capacity building differences, tying to Sam's talk. And I think all these can be really nicely highlighted to raise awareness and also to maybe leverage for potential new opportunities or new funding. And what I wanted to propose, and this is certainly an effort that you guys are leading, but I was thinking that maybe we could have a couple of outputs. In essence, this session is maybe a little bit where the tire hits the road, the rubber hits the road, in that what are tangible things that we can now do going forward. And I was thinking that we could highlight the nuances in these three different regions in a policy document. And very graciously, Sebastian and Kai from Future Earth's Coast have offered to maybe help in that process to deliver a policy document that kind of ties Africa, OA Africa together. So that might be one potential output. I was also thinking, because a lot of work has gone into these regional assessments on OA already, that we could maybe write a paper for Frontiers in Marine Science as an example that highlights a little bit more in detail the science and the differences and the commonalities in these different regions in a scientific paper. And I think those two things would be something that I would be very keen to talk to you about and to look forward to seeing how we want to implement those. So that was a comment on the white papers. Now looking forward, there's two opportunities that I think could potentially be interesting for OA Africa. And one of them is our COP26 meeting that is in Glasgow, November of this year, and seeing if we want to organize ourselves around a side event or something strategic to showcase all the work that has been done in OA Africa. And the second one deals with, again, going back to the decade of ocean science, our brave new ocean. There might be ways to organize ourselves in a particular way related to that. And I just wanted to mention that some of you were involved with me on putting together a program for consideration with the EGP, the Executive Planning Group, I believe it's called, through the decade, that is going to assess everything from project levels up to programs for consideration in the decade. So GOA-ON and kind of global ocean acidification activities are getting some voice if it happens through the decade, but we might want to also think about other more Africa regional things that we want to think about for the decade. So that's my two quick comments on that. Thanks. Back to you, Trevor.
Okay, thank you, Peter. What I'd like to pose now is the question to each of our participants, and you have about a minute to respond. Well, to Naira, Sheikh, and Roshan, actually, what would be one or two policy recommendations or strategic outcomes that you can identify from the work you've done? What would you? And go ahead, Naira, would you like to start? Did you hear me?
I could start.
Okay, Sheikh, why don't you start then? Go ahead.
Well, this is a recommendation for West Africa, but I'll also look to see if the rest of the region, step up with this. I know the different areas or regions are assigned or belong to different regional seas program of the UN Environment or UNEP. First thing, like what we started as an outcome of this event, to have a draft resolution. And the draft resolution is going to reflect the activities, the discussions, the opportunities, the challenges, the prospects, and the different perspectives from the different region, that we can give that out. And we ask at least a country from previous discussion to submit that to one of the UN or regional seas program, whether it's going to be the Abidjan Convention or it's going to be the Nairobi Convention. And based on that, we can have an MOU signed between 1, 2, 3 parties that will highlight the different rules and responsibilities, and will be signed by head of the different institutions, whether the OAICC or the Ocean Foundation or the OA Africa Network or the Nairobi Convention or what have you. And after an MOU is signed, the next step is to develop a work plan, and that work plan now can range from science to policy interaction, or from Patrizia's presentation talking about the integration of, the bridging the gap between natural sciences and social sciences and things like that. So, from my understanding of view, I think that was the essence for us starting up the this event to discuss ways and means around keeping the network active, keeping the network discussing and focusing on the core objective, but also having an output that will be consolidated or integrated enough to draft a regional policy action from science, of course, to policies. So I will stop there for now, but I was hoping that the entire region takes a similar approach to reflect more holistically what the OA Africa Network is trying to push in terms of ocean acidification, awareness and research.
Okay.
So I can add to my colleague Chuck point of view that for North Africa and for all Africa, we are looking for inclusion of more scientists, more researchers to work and to make their scientific research easier by providing mentorship, information, exchanging data together to help for creation and developing a general overview for the 3 different coastal areas for North Africa or West or South or East Africa. Also, as Sam mentioned in his presentation, that a lot of funding agency, GOA-ON, IEA, IOC, UNESCO, Future Earth, Ocean Foundation provides too much money, invest a large amount of money, provide kits, provide many trainings. So what we need is to take one step forward for inclusion of more researchers and knowledge transfer of these knowledge taken through the previous training and build a high capacity of researcher and scientists for monitoring, for continuous monitoring of ocean acidification, put more effort for socio-economy. As my colleague mentioned, my Czech mentioned that we need to move forward for the policy maker and grab attention of the public and the policy for decreasing the carbon dioxide emission and ocean acidification and highlighting the impact on economy, which is greatly affected the people in Africa, either North, West, East Africa or South Africa. So I agree with Sam that we moved forward and we achieved a lot in Africa, but we need more. We are looking for more successful stories such as Carla Falilu. Falilu is one good example of that. He got a scholarship and he started to build the community, to start research in Gulf of Guinea with the help and support of Sam and Patrizia. We need more successful story in Africa, and already what we achieved during the last 5 years by the help and support of the funding agencies that work and paid a lot of effort, time for the capacity building of African scientists. We need more. We need to, as you said, check, and my colleague Roshan investigate that. There's an inclusion of East Africa, of many countries, of a large number of scientists. They started from the scratch and now they have data, more publication. So the situation is very optimistic, and we try to just raise the awareness as much as we can and include more researchers and put more light on the importance of ocean acidification for African socio-economy. And okay, let's just say that raise the awareness for need of action for stop more carbon dioxide emission, which is directly decrease the pollution for coastal areas, preserve the coastal area from degradation, so we can conserve our coastal areas. That's I think that's the main benefit from such meetings and the goal for the OE Africa. Thank you.
Thank you, Naira. Roshan, you want to say something? And then I have to say, because we're already over time and we still want Chibo to be able to give her presentation, that we'll let Roshan speak, and then we're gonna move over to Chibo, and then at the end, if people still want to stick around, we can open up the conversation to questions. All right, so Roshan, go ahead. You're muted. 1 second.
Muted.
Unmuted.
Yep.
There we go.
Yep. That's okay. Yep. So coming back to the policy, I would say that we're trying to work towards a platform. I mean, usually we're using the WAMSA to provide a platform to enable many of the cross-cutting activities, like science action to create knowledge and develop solutions, communication action to raise awareness, and policy action to change the future. And one of our recommendations, which will be put ahead to the Nairobi Convention, would be to ask policymakers to recognize the threat posed by OA and for political support for further development, expansion, and enhancement of this area of research in the region. So you will see that WAMSA is expanding science coverage, and which may eventually help support regional policies to confront OA. And we believe that the Nairobi Convention can critically assist with the highly needed strategic focus on OA in the Western Indian Ocean region. And various policy action to change the future, like strengthening existing local source control programs, or apply more stringent controls on nutrient or organic carbon pollutants to achieve the needed reductions in nutrient and organic carbon pollutants. We have to reduce other stresses in the marine environment to enhance overall ecosystem resilience, support regional and national monitoring and research efforts, supporting the development of adaptation and mitigation strategies for and to ocean acidification. Also implement science-based adaptation and mitigation strategies targeting ocean acidification, support the implementation of the 14.3.1 indicator methodology, and protect natural carbon sinks such as seagrass beds, mangroves, under application of sustainable management tools such as MPAs and ICZM. So there's a lot to be done, and as I said, the economic importance of OA on fisheries and tourism is likely to be substantial and may include loss of profits and employment, may even lead to loss of coastal infrastructure. So due to decreased storm protection facilitated by reefs as a consequence. So these are some of the recommendations that will, in terms of policy level. That's why we need to move from science to a policy language to be able to bring this to the next level. That's
well spoken. Okay. Yeah. So now we're going to let Chibo come in and give the presentation that we weren't able to load previously. Thank you to the panelists. I wish we had more time to talk about these issues because it is an interesting question, and I think there was a lot more to be said. If you feel like sticking around, or if you have time after Chibo's presentation, we're going to open up the floor. I know Patrizia had a question, and you're welcome to stay and keep talking. So now I am going to present the presentation, and Chibo, you're welcome to turn on your mic. What you can do is at the end, you can see where the slides are on my screen, and then you can say next slide, or you could just pause for a few seconds and I will automatically move the slide forward. So that's what we're going to do. Sharing my content now. First, I'm the presenter.
Okay, hello again, everyone. In the interest of time, I'm going to highlight specific aspects from my slides and elaborate on those. So if anybody wants to ask any other questions in between, then you can probably just get back to me at any time. Then at least we have more time to have like further discussions. I'd like to thank Shrek and everyone, the organizers, for allowing me to present. You can go to the next slide. Oh, sorry, I forgot to say, I'm focusing on the Benguela upwelling system. So again, everything that I think it was Kai said essentially relates to this. The only aspect here that I would focus, the northern Benguela is actually separated between the northern Benguela and the southern. So the northern is most predominantly part of Namibia, and we're actually a carbon dioxide source, whereas the south is a carbon dioxide sink. So these aspects and the fact that we have upwelling, high primary productivity that leads to remineralization, all of that are aspects of what makes the Benguela upwelling system significant with respect to ocean acidification. Even though this is true, there wasn't a lot of information with respect to that, especially for the northern Benguela as well as Angola. So if you look at a lot of the information, because even that, the fact that we're a source, if you look at the data that is based on, it's very patchy and there's no actual aspects of seasonality in that. So it's just taken as is, but we're not too sure what the extent of that is. So you can go to the next slide. So for the region itself, where this came into play was when the FAO and the Nansen project that Mohammed was talking about was where they decided to actually do, the coast do cruises along the whole coast of western and southern Namibia, southern Africa. So this was the first instance where we actually had quite a large data set with respect to normal parameters as well as the pH. And if you look down there, what I have here is with respect to the temperature, oxygen, and pH, and it's from the southern part of Angola down into Namibia. Now, this data, as Mohammed was talking about, is still being processed, and they've been 2 cruises. But the cruise, especially this first, which I was a part of, was a cruise for pelagic fish. Pelagic fish. So the transects that we did were literally related to where the fish were. So that data was repeated for 2019, those transects, and they included others. So the data set for all of these aspects, as well as carbon and chemistry parameters, including total alkalinity, is actually getting bigger. At the moment, it's being processed, and then that's when we'll get an idea of some level of baseline. So with this in mind, and with what came from the survey, they realized that there was an issue with respect to the fish stocks, and we started looking at climate change aspects, and that is when, as a region, they realized that they would have to actually try and see what are the effects of oceanification in this area. And because we're a large marine ecosystem, yes, it's the Benguela, but we include Angola. So we got regional funding to actually look at 2 aspects, look at oceanographic monitoring and looking at biological projects themselves in order to get an idea of basically baseline studies, what's going on with respect to carbon chemistry, as well as what level of seasonality there is, what effects the upwelling and the primary production have with it. And what's good about this is the first instance where we got funding for the region itself, and it is geared towards each of the 3 different countries, because we all, as you saw with Sam's presentation, we all have different levels of expertise. And for this area, the common industry that was featured for all was basically shellfish, which is the shellfish mariculture. So the projects that we wanted to do had to link into that in some way. You can go to the next slide. You can go to the next slide. No, back one. So for South Africa, back one.
I'm sorry.
No.
There you go.
Don't worry. Why back one? Yeah, so for South Africa, they have, when it comes to the carbon and chemistry system, I think they can measure just about everything that is. They also have mooring stations, so the resolution of their data is quite large, though it is focused on specific areas.
Je crois qu'il est passé. Je l'ai pas vu.
Okay.
On est encore là, hein, ton...
So, with this in mind...
Hier, je l'ai vu, et je lui ai dit que tu avais des problèmes, s'il peut me porter, et malheureusement, je ne l'ai pas vu.
Go back
en fait, je te le dis parce que j'ai vu que le café est plein, donc...
Yeah, just stop there. Okay, I think I will just end with... with this, no, the next one. Pack one. Yeah, stop there. Okay, I will just end with this slide in the sense that we're saying with the 3 regions, each region we're looking at specific things. For Namibia specifically, the monitoring that we have was very sparse and patchy. So with this project, we're going to be able to have more regular sampling. And the most important thing is the fact that we'll be able to get quality assurance aspects because we have funding for the CRMs and all the other aspects. And we're linked to South Africa, so our capacity is going to be raised with respect to that. And for the biological experiments, we're going to be focusing on micro and macroalgae because that is my area of interest. So looking at laboratory experiments, looking at toxin concentrations in relation to the effects of climate change. So this would be pH as well as temperature changes, and see how this relates to the larval development as well as the feeding in the shellfish. And then as well with the macroalgae, looking to see which species can actually sequester the carbon dioxide most readily. And one of the outputs for this regional project is going to be a white paper, which will also include Angola. So this is one of the deliverables that can probably feed into OA Africa as well. And I think I will just end it there.
All right, thank you, Chibo. I'm glad we got you in here to speak because
patchy, but sorry.
This is a really good project. and you put some good work into these slides. Okay, so our event is pretty much concluded. I want to thank all the participants, the panelists, the attendees for joining us today to promote the research of ocean acidification in Africa and to hear about the latest science and capacity building going on. Now we're going to open up the floor to the speakers here, and we're going to return to our panelists who are going to stay on just for at least a few more minutes to talk and conclude with their statements. Does that sound good, everyone? If you need to go, we totally understand. And otherwise, you're welcome to stick around for a little bit longer. So I'm going to stop sharing. And let's see, we had a question from Patrizia. So Patrizia would like to ask the panelists, what are the main challenges in addressing the strategies of OA research in Africa in each of your regions, and how can these challenges be addressed? So it's kind of two components there, but what are the challenges for strategizing OA research in your regions? Anyone, Roshan or Sheikh, Naira?
Maybe I will start, and I hope I'm direct with responding to Patricia's question or query. I think you heard from the presentation from West Africa, Falilu, and also my summary introduction or introductory talk about the white papers. West Africa is kind of lagging in terms of ocean acidification research and science. I mean, although there were members that currently still with the network, that have been with the network, they are founding members since 2015, but they are still there. Absolutely, I don't want to say absolutely, but West Africa does not have the right set of laboratory for ocean acidification research, but in the right to say there is a lack of technical and financial capabilities. We don't have the laboratories, we don't have the funding, and I think at this stage the support is kind of lacking as compared to other regions that we spoke about. For example, the Indian Ocean region, East Africa, and part of North Africa. So these are some of the challenges. Now, out of that, I think this encapsulates everything about the research pertaining to ocean acidification. There is an opportunity in Ghana starting the BioTap project, of course, with the Pogo network thing. But the laboratory at the University of Ghana and the Department of Fisheries and Marine Sciences is not built succinctly to support OA research in totality. And I'm sure Edem will back me into that. So, I mean, to cut this short, I think to address this issue, and it goes back to Patrizia and other partners, it is going to be important that West Africa, of course, get some attention, and I'm emphasizing West Africa because to ensure that we close these data gaps, it is essential to make sure that all of the regions of Africa are equally covered, even if not 100%, but in part and parcel. So to close these gaps, we understand there's a lot been done in East Africa. There's pretty much been done in North Africa. We're hoping to see over the next 2 years, I mean, with the operationalization of the network to what we are foreseeing it to be, to ensure that West Africa gets on track in terms of capacity building, in terms of training, laboratory techniques, laboratory setups, and chemicals, equipment, and things like that. So I think I'm sure, yeah.
Please try and keep the responses under a minute so we have time to go over a few of these things, because I still want Naira and Roshan, if you could give a response to that with the strategic challenges for you developing OA research.
Okay, I can say some few words. For North Africa, I think not all labs have the same equipment and facilities. Some countries such as Libya, due to the political situation, that there is no any connection for scientific researchers from Africa, from Libya. Also, I think the main challenge is the integration, and this could be also could be only happen or achieved through the cooperative projects, because I think for the aspect of trainings and capacity building for researchers, it's already done, and there's a large number of scientists that is there. They are working already in ocean acidification. Such as Sam said that it's money governs, but we can start in a way that they made the scientist life easier by publishing papers and set some ways for measurements of parameters in a very simple, by a very simple instrumentation. What's actually needed is integration and cooperation. That's the main challenge, to have one complete picture for North Africa.
Okay, thank you. Roshan?
Well, I agree with both Naira and Sheikh. I mean, we know that oil research is still expensive and remains inaccessible. Therefore, I mean, as I said, there is a need to be able to refine certain systems to lower their cost and to make them more user-friendly for resource limited. And once and the Nairobi Convention, well, may support this effort. And for example, using sensor systems or modular low-cost analysis systems that can be easily repaired or easy to operate well. Risk reduction systems for aquaculture that are stable for small-scale operations in resource-limited contexts. I mean, these are advances that could help make it more accessible to a majority of coastal communities working in the field of ocean acidification. This is the major challenge at the moment, getting quality control equipment and so on. But at the moment, we are still working towards these and experimenting and doing some pilot projects. And this will be the challenge for the next couple of years for most of the labs to be fully efficient and to be performing. Thank you.
Thanks. Hey, I just wanted to say really quickly, Carolina has been with us on the line this whole time, and she's our new staff member at the OAICC, as you can see her on the video feed. And just if you're, feel free to say hi, Carolina, really quickly. We're glad to have you. Your mic, you're muted. You don't have. That's all right. Well, Carolina's here. If she connects her mic later, she can say hi. Okay, so Peter, do you want to maybe wrap this up for us and help us conclude the meeting?
Yeah, Trevor, I would be happy to. So just listening to the conversation over the last half an hour or so, I'm stricken with that there are really commonalities in each one of the different regions, and maybe one of the ways forward is to help design a roadmap of sorts for OA, and this would be interpreted slightly different for each one of the regions, but I think the end goals could be clearly defined, and that would allow us to kind of pass towards trying to get there. And I think I remember Noah put forward a roadmap for ocean acidification that came out not that long ago, and in many ways, you know, we have a tremendous will with OA Africa. We have a lot of capacity, and certainly the regions, each one of the three regions are really interesting. And I think, as has been brought forward today, it's tremendously compelling because of the impacts to fisheries and coastal communities. And so if the OAICC, if we can help in any way in trying to collect this energy in a sort of a roadmap, I think we would be really happy to do that. But looking back now, what we've accomplished, from January 8th and again today. I'm really impressed with the amount of energy and creativity and will in trying to put ocean acidification at the forefront of ocean change for many of you, and I think this is really great. And we're really proud to be part of this as the OAICC. So I thank you very, very much for your time, and hand it back to you, Trevor. I need to probably get off in a couple of
Yeah, we're ending the meeting now. I'm sure there's more to be said, and then if you would like to say more, go to the OA Information Exchange, to the Africa team, where I've posted a post-event chat about the event, and we can keep the conversation going at your leisure. In the meantime, take care, enjoy lunch. I'm sure you're all hungry or, got lots of things to do, and it's much appreciated that you could be with us today. Have a nice day. Enjoy your weekend.
Thank you very much. Thanks.
Bye.
See you. Bye-bye.
Bye-bye.
Bye. Thank you.
Bye, everybody.
Okay.